Video here on TryHackMe. I'm John, and today we're going to be taking a look at the room Packets and Frames. Understand how data is divided into smaller pieces and translated across the network to another device. That being said, let's go ahead and dive right into task 1. What are packets and frames? Packets and frames are small pieces of data that, when formed together, make a larger piece of information or a message. However, they are two different things in the OSI model. A frame is at layer 2, the data link layer, meaning there's no such information as an IP address at that specific layer. The data link layer, meaning there's no such information. They are two different things in the OSI model. A frame is at layer 2, the data link layer, meaning there's no such information as an IP address at that specific layer. Think of this as putting an envelope in, or within an envelope and sending it away. That's the encapsulation process that we mentioned in a previous room. The first envelope will be the packet that you mail, but once it is opened, the envelope within still exists and contains data. And this is called a frame. So you can see that we're taking the different data structures that are present at each layer and causing, we have encapsulation and subsequent de-encapsulation, breaking that down so that everything is processed correctly. And here you can see again, this process is called encapsulation, which we discussed in room 3, the OSI model. At this stage, it's safe to assume that when we are talking about any Anything IP addresses, we're talking about packets. When the encapsulating information is stripped away, we're talking about the frame itself. Packets are an efficient way of communicating data across network devices, such as those explained in Task 1. Because this data is exchanged in small pieces, there's less chance of bottlenecking occurring across a network than large messages being sent at once. So if we were trying to send a lot at once, we might slow down and potentially take down the network. That can happen. But by we're sending small packets, we have a far, far smaller chance of that actually occurring. For example, when loading an image from a website, this image is not sent to your computer as a whole, but rather small pieces where it is reconstructed on your computer. Take the image below as an illustration of this process. The dog's picture is divided into 3 packets, where it is reconstructed when it reaches the computer to form the final image. So here we can see it's broken down into smaller pieces of information, and then it can be rebuilt back up into that big message, or in this case, the picture of the dog. Packets have different structures that are dependent upon the type of packet that is being sent. As we'll come on to discuss, networking is full of standards and protocols that act as a set of rules for how the specific packet in question is handled on a device. With the internet predicted to have approximately 50 billion devices connected by the end of 2020, things quickly get out of hand if there are no standardization. Let's continue with our example of the Internet Protocol. This is something that we discussed in a previous room. If this is not necessarily making sense, I recommend backtracking and reviewing these concepts before continuing on. A packet using this protocol will have a set of headers that contain additional pieces of information to the data that is being sent across the network. Some notable headers include time to live. This is the field that sets an expiration timer for the packet to not clog up your network if the packet in question never manages to reach a host or escape. So if that goes down to 0, it just is deleted or discarded by a router. Checksum. This field provides integrity checking for protocols such as TCP/IP. If any data is changed, this value will be different from what was expected and therefore corrupt, and that's a sign that it needs to be resent. Source address, the IP address of the device that the packet is being sent from, so the data knows where to return to. And then we have the destination address, the device's IP address that the packet is being sent to, so the data knows where to travel next. Let's dive into the questions. What is a name for a piece of data when it does not have IP addressing information? I believe that should be packet in this specific case. And there we go. What is the name for a piece of data when it, this is when it does have the IP addressing information. How about when it does not? That would be a frame. And there we go. Let's move into task 2, TCP/IP, with a 3-way handshake. TCP, or the Transmission Control Protocol. TCP, or the Transmission Control Protocol for short, is another one of these rules used in networking. This protocol is very similar to the OSI model that we have previously discussed in the room 3 of this module so far. So just to break this down and take a step back, OSI model and the TCP IP model, they're two different ways of talking about how things happen on a network. So this is different from just TCP. This is a combination of the TCP IP protocols into another model. So just taking a step back because this can be a little confusing when it's first approached. So the TCP IP model consists of 4 layers and is arguably just a summarized version of the OSI model. These layers are the application layer, so this is the top one, transport, internet, and then the network interface. Very similar to how the OSI model works, information is added to each layer of the TCP model as the piece of data or packet traverses it. As you may recall, this process is known as encapsulation, where the reverse of this process is called de-encapsulation. One defining feature of TCP is that it is connection-based, which means that TCP must establish a connection between both a client and a device acting as a server before data is sent, because that session needs to be built up. Because of this, TCP guarantees that any data will be received on the other end. This process is known as the three-way handshake, which is something we'll come to discuss shortly. A table comparing the disadvantages and advantages of TCP is located below. And I won't go into this was covered in a previous room, just know that TCP does, it's going to ensure that your data that is sent and received is accurate and what you're getting is what you were promised, but it can have a bottleneck because of that. TCP packets contain various sections of information known as headers that are added from encapsulation. Let's explain some of the crucial headers in this table below. So first we have the source port. This is the value the port opened by the sender to send the TCP packet from. This value is chosen randomly out of the ports 0 to 65,535 that aren't already in use in that time. And then we have the destination port. This value is the port number of an application or service that is running on the remote host, the one receiving the actual data, so the server in this case. For example, a web server running on port 80. Note, this isn't necessarily always a server. This can go back and forth. Just know that the server is within our general metaphor that we're using right now. Unlike the source port, this value is not chosen at random. We have our source IP, which we covered previously. This is the IP that's sending the data, and then we have destination, which is where it's going to go. Next, we have the sequence number. When a connection occurs, the first piece of data transmitted is given a random number. We'll explain this more in depth further on. And then we have the acknowledgement number. After a piece of data has been given a sequence number, the number for the next piece of data will have the sequence number plus 1. We'll explain this more again further on in the room. Next, we have the checksum, which we've covered previously. This is a number that is used by a mathematical formula that guarantees that the data in the packet has not been corrupted. If it doesn't match what it should match, then the packet needs to be resent. Then we have the data, which is where the data, i.e. the bytes of the file, is being transmitted and stored. And then we have flags. This header determines how the packet should be handled by either device during the handshake process. Specific flags will determine specific behaviors, and we'll talk about that here in just a little bit. Next, we'll come on to discuss the three-way handshake, the term used for the process used to establish a connection between two devices. The three-way handshake communicates using a few special messages. The table below highlights the main ones. First, we have SYN, or step 1. A SYN message is the initial packet sent by a client during the handshake. This packet is used to initiate a connection and synchronize the two devices together. We'll explain this more further on. Next, we have the SYN-ACK step. This packet is sent by the receiving device, or the server, in this the case of the metaphor that we're using, to acknowledge that the synchronization attempt from the client has succeeded. And then we have the ACK step. The acknowledgement packet can be used by either the client or server to receive, or to acknowledge that a series of messages/packets have been successfully received. So what we're doing here is we're setting up the handshake. First we have, and we'll go down to the actual setting up the connection, this diagram here. We have Alice that wants to talk to Bob. First, Alice is going to send a SYN packet, which is requesting to synchronize and open the connection, and then Bob sends back a SYN, which is the synchronization number. Again, this is just so that we know that our packets are going in order because it's going to increment by 1, and we're also going to acknowledge that we received that SYN packet. So we have SYN and ACK sent back. And then Alice needs to acknowledge that we have received that SYN packet, setting up the actual synchronization of the packets there, and confirming that the connection is active by sending another acknowledgement packet. Let's go ahead and talk about the other few flags here. Number 4, we have the data, which is once the session has actually been established, the data is sent via data message, so that's the actual flow of information back and forth. Once we're done sending data, we'll send a FIN packet, which is used to cleanly or properly close the connection after it has been complete. So say I'm done with my video call with you, and we want to close the connection. We'll send a FIN packet, and then we end it with a reset packet. Or this packet, it's another way of breaking down the communication. It abruptly ends all communication. This is the last resort and indicates there was some problem during the process. For example, if the service or application is not working correctly, or the system has faults such as low resources. So typically we're going to send this FIN packet to end the actual connection, but if there are problems, we'll send a reset packet. Again, this is how the opening that handshake, the three-way handshake, actually happens in diagram form. Any data sent is given a random number, and again, this is what I broke it down before. So we're going to start with a random number, and it's going to be incremented by 1 each time we move through this step, and that's just confirming that the data sent and received has been done so in the correct order. And you can see that broken down here as well. TCP closing a connection. Let's quickly explain the process behind TCP closing a connection. So first, TCP will close a connection once a device is determined that the other device has successfully received all of the data. Again, I briefly touched on this before, but we can see how we're sending the FIN packet here, and then we're acknowledging it, sending another FIN packet back, and then sending another acknowledgement packet. So very similar to the three-way handshake, except these are two separate requests that happen here. But again, we're just breaking down that communication very much in the same way that we set it up. Let's go ahead and dive into the questions. What is the header in the TCP packet that ensures the integrity of data? That is the checksum. There we go. Provide the order of a normal three-way handshake. That is going to be SYN, Sin, Ack, and then Ack. There we go. Let's move into task 3, Practical Handshake. Help Alice and Bob communicate by reassembling the TCP handshake in the correct order. transporter in the static lab attached to this task. Enter the value of the flag given by completing this task. Let's go ahead and dive in. The user datagram protocol is another protocol used to communicate data between the devices. Unlike its brother TCP, UDP is a stateless protocol that doesn't require a constant connection between two devices for data to be sent. For example, the three-way handshake doesn't occur in this case, nor is there any synchronization between the devices. Recall some of the comparisons made between these two protocols in Room 3, the OSI model. I'm going to go ahead and skip past this since we've gone ahead and already covered this. If you want to, make sure that this is in your notes, but otherwise we'll continue on. As mentioned, no processes can take place, and they don't actually set up a communication or connection rather between the two devices, meaning there's no regard for whether or not the data is received, and there are no safeguards such as those offered by TCP, such as data integrity. UDP packets are much simpler than TCP packets and have fewer headers. However, both protocols share some standard headers, which are what is annotated in the table below. So we've talked about these before. We have time to live, source address, destination address, source port, destination port, and then the actual data. So pretty simple, much simpler than the TCP packet because we don't have checksums and we don't have other things that are at play. Next, we'll come on to discuss how the process of a connection via UDP differs from that of something such as a TCP connection. We should recall that UDP is stateless. No acknowledgement is sent during a connection. The diagram below shows a normal UDP connection between Alice and Bob. In real life, this would be between two devices, so we're requesting that data, and then all the data just keeps getting sent back. What does the term UDP stand for? That is User Datagram Protocol. What type of connection is UDP? That is stateless. What protocol would you use to transfer a file? Hopefully TCP. And then what protocol would you use to have a video call? Hopefully UDP. Let's move into Task 5, Ports 101, Practical. Let's go ahead and load the site. Perhaps aptly titled by their name, ports are an essential point in which data can be exchanged. Think of a harbor and a port. Hey everyone, welcome back to another video here on Try. Hopefully UDP. Let's move into task 5, ports 101. Hey everyone, welcome back to another. Video here on TryHackMe. I am John, and today we'll be talking. Port forwarding is an essential component in connecting applications and services to the internet. Without port forwarding, applications and services such as web servers are only available to devices within the same direct network. Take the network below as an example. Within this network, the server with an IP address of 192.168.1.10 runs a web server on port 80. Only the two other computers on this network will be able to access it, and this is known as an intranet rather than an internet. So you can see we have our server here and then a couple other computers. If the administrator wanted to make the website to be accessible to the public using the internet, they would have to implement port forwarding like in the diagram below. So here we can see that when someone visits this IP address on port 80, it's forwarded to this computer on port 80, and that's where we have port forwarding at play. With this design, network number 2 will now be able to access the web server running on network number 1 using the public IP address of network number 1. It's easy to confuse port forwarding with the behaviors of a firewall, a technology we'll come to discuss in a later task. However, at this stage, just understand that port forwarding opens specific ports. Recall how packets work. In this specific case, you can see that it's just taking this and passing it along, just forwarding the connection. In comparison, firewalls determine if traffic can travel across these ports, even if the ports are opened by port forwarding. Port forwarding is configured at the router of a network. What is the name of a device that is used to configure port forwarding? That's what we just mentioned. That'll be the router. Let's move on to task 2, Firewalls 101. A firewall is a device within a network responsible for determining what traffic is allowed to enter and exit. Think of a firewall as border security for a network. An administrator can configure a firewall to permit or deny traffic from entering or exiting a network based on numerous factors, such as where the traffic is going, so source and destination port and address, so where it's coming from, where it's going to, what port is the traffic for, what protocol is the traffic using, so for example, has it been told to allow SSH or allow UDP, allow TCP, further things like that. You can get pretty fine-grained with these things. Firewalls perform packet inspection to determine the answers to these questions. Firewalls come in all shapes and sizes, from dedicated pieces of hardware, very common to find in businesses, so large networks like that can handle a magnitude of data, to residential routers like at your home or software such as Snort, and firewalls can be categorized into 2 to 5 categories. We'll cover the 2 primary categories of firewalls in the table below. First we have stateful and then we have stateless. Moving on with stateful. This type of firewall uses the entire information from a connection, rather than inspecting an individual packet. This firewall determines the behavior of a device depending on if the connection has been opened. So it's based on the entire connection, the entire history, rather than just that packet at that point in time. This firewall type consumes many resources in comparison to stateless firewalls, as the decision-making is dynamic. For example, a firewall can allow the first parts of a TCP handshake that would later fail. If a connection from a host is bad, it will block the entire device. Again, stateful firewalls are very cool, but they're much more resource-intensive. Moving on to stateless firewalls. This firewall type uses a static set of rules to determine whether or not individual packets are acceptable, or if they're just going to be blocked. For example, a device sending a bad packet will not necessarily mean that the entire device is then blocked. Whilst these firewalls use much fewer resources than the alternatives, they're a lot just simpler. For example, these firewalls are only as effective as the rules that are defined within them. If a rule is not exactly matched, then it is effectively useless, so we have rules that determine these packets at this point in time, rather than considering the connection at large. However, these firewalls are great when receiving large amounts of traffic from a set of hosts, such as a distributed denial of service attack or DDoS attack. Let's move into the questions. What layers of the OSI model do firewalls operate at? That would be, I believe, layer 2 and layer 3. Let me go ahead and check my notes real quick. There we go. Had them in the wrong order. So layer 3 and then layer 2. virtual private network, or VPN for short, is a technology that allows devices on separate networks to communicate securely by creating a dedicated path between each device over the internet, known as a tunnel. Devices connected within this tunnel form their own private network. For example, only devices within the same network, such as within a business, can directly communicate. However, a VPN allows two offices to be connected, so we can have a VPN that forms a route between those two offices rather than just from one device to another. It allows one device or one network to communicate with another device, or another network rather. We're just creating a tunnel, so to speak. So here in this diagram, we have the network 1 here, network 2 here, and then we have network 3 with a VPN. The devices connected on network 3 are still part of network 1 and network 2, but also form together to create a private network, so these are on their own network. Then only devices that are connected via this VPN can communicate over. Let's cover some of the other benefits offered by a VPN in the table below. So some benefits with this allows networks in different geographical locations to be connected. They offer privacy because it is a private connection there, and there's typically encryption at play. Offers anonymity because you can route your traffic throughout another region. You can encrypt that traffic and push it out a different way, so it doesn't look like it's coming from you. And then there's a couple other minor benefits, but we won't get into those right now. Those are the major items. TryHackMe uses a VPN to connect you to our vulnerable machines without making them directly accessible on the internet. This means that you can securely interact with our machines. Service providers such as ISPs don't think you're attacking another machine on the internet, which could be against the terms of service, so it keeps you safe. And then the VPN provides security to TryHackMe, as vulnerable machines are not accessible using the internet, so they're not susceptible to bots in that specific way. VPN technology has improved over the years. Let's explore some of the existing VPN technologies below. First, we have PPP. This technology is used by PPTP, explained below, to allow for authentication and provide encryption of data. VPNs work by using a private key and public key certificate, similar to SSH, so you have a way that you don't have to send your key over the network. A private key and certificate must match for you to connect. This technology is not capable of leaving a network by itself, so it's non-routable. Don't worry too much about this, and all of these protocols, it's just something to know that they exist. As you advance in your career, this is something that you'll dig into further when you start examining network security at a more fine-grained level. Let's move into PPTP. The point-to-point tunneling protocol, or PPTP, is the technology that allows the data from PPP to travel and leave a network. This protocol is very easy to set up and is supported by most devices. It is, however, weakly encrypted in comparison to alternatives. And then last but not least, we have IPsec. Internet Protocol Security, or IPsec, encrypts data using the existing IP protocol. IPsec is difficult to set up in comparison to alternatives. However, if successful, it boasts strong encryption and is also supported on many devices. Again, don't worry too much about the specifics here, just know that these exist. What VPN technology only encrypts and provides authentication to data? That is PPP. What VPN technology uses the IP framework? That is IPsec. Perfect. Let's move into task 5, LAN networking devices. First, let's talk about what a router is. It's a router's job to connect networks and pass data between them. It does this by routing, hence the name router. Routing is a label given to the process of data traveling across networks. Routing involves creating a path between networks so this data can be successfully delivered. Routers operate at layer 3 of the OSI model. They often feature an interactive interface, such as a website or a console. Website's pretty common in the case of even most business routers at this point, but this is going to be what you interact with on your home network, that allow an administrator to configure various rules, such as port forwarding or firewalling. Routing is useful when devices are connected by many paths, such as in the routing or the diagram below, where the most optimal path is ultimately taken. Routers are dedicated devices and do not perform the same functions as switches. We can see that router A or computer A's network is connected to the network of computer B by two routers in the middle. So we have the network of computer A and then the network of computer B. And we have these two middle devices that are presumably also routers given the symbol used. The question is, what path will be taken? Different protocols will decide what path should be taken, but factors include what path is the shortest, what path is the most reliable, and which path has the faster medium, so copper or fiber, so on and so forth. We've already talked about this in a previous room, so we'll go ahead and move on. What is a switch? A switch is a dedicated networking device responsible for providing a means of connecting to multiple devices. Switches can facilitate many devices from 3 to 663 using Ethernet cables. Switches can operate at both layer 3 and layer 2 of the OSI model. However, these are exclusive in the sense that layer 2 switches cannot operate at layer 3. Don't worry too much about that right now, just know that switches can either be at layer 2 or layer 3. Take, for example, a layer 2 switch in the diagram below. These switches will forward frames. Remember that there are no longer packets as the IP protocol has been stripped onto the connecting devices using their MAC addresses. So we're just sending things onto other devices using the MAC address in this specific case. Think this is just layer 2, this is the data link layer in this specific instance. These devices are solely responsible for sending frames to the correct device. So this computer sends something here, and the switch itself has that MAC address saved in the ARP cache here, and it'll forward it along. So pretty straightforward. Now, let's move on to layer 3 switches. These switches are more sophisticated than layer 2, as they can perform some of the responsibilities of a router. Namely, these switches will send frames to devices, as layer 2 does, and route packets to other devices using the IP protocol. Let's take a look at the diagram below of a layer 3 switch in action. We can see that there are two IP addresses. So we have 192.168.1.1 and then 192.168.2.1. A technology called VLAN, or Virtual Local Area Network, allows specific devices within a network to be virtually split up. This split means they can all benefit from things such as the internet connection that comes in, but are treated separately. This network separation provides security because it means that rules are in place to determine how specific devices can communicate with each other. This segregation is illustrated in the diagram below. So here we might have one VLAN for the sales department and another for accounting. Don't worry too much about that right now, just know that this is a way that we can divide up networks. In the context of the diagram above, the sales department and the accounting department they'll both be able to access the internet, as seen up here, but will not be able to communicate with each other if that rule is in place, although they are connected to the same switch in that manner. Let's move into the questions. What is the verb for the action that the router does? I believe that should be routing. There we go. What are the two types of switches? Separate these by comma. Should be layer 2, layer 3, I would imagine. And there we go. Let's move into task 6, Practical Network Simulator. Go and load the site, and then we're going to go ahead and complete our tasks. Deploy the static site attached. Hey everyone, welcome back to another video here on TryHackMe. I'm John, and today we're going to be taking a look at the room DNS in detail. Learn how DNS works, and how it helps you access internet services. That being said, let's go ahead and dive into task 1. What is DNS? DNS, the domain name system, provides a simple way for us to communicate with the devices on the internet without remembering complex numbers. Much like every house has a unique address for sending mail directly to it, every computer on the internet has its own unique address to communicate with, called an IP address. An IP address looks like the following. So you can see this is 4 sets of numbers ranging between 0 and 255, and we can see that right here as well, separated by a period in between these. This is referred to as 4 octets. That is because it comes from the binary notation of this. You'll see this in other representations as well if you go down that addressing, learning about that a little bit more. When you want to visit a website, it's not exactly convenient to remember this complicated set of numbers, and that's where DNS can help. So instead of remembering this exact IP here, you can remember TryHackMe.com instead. So here you can see that we have an example DNS record that would be for TryHackMe.com that would point to the IP address here. Let's see. For the question, what does DNS stand for? That is the domain name system. And there we go. Let's move into task 2, domain hierarchy. First, let's talk about TLD, or top-level domains. Let me close my streak here. A TLD is the most right-hand part of the domain name. So, for example, the TryHackMe.com TLD is .com, and you can see that broken out up here, where we have the period, and then we have our TLDs listed here. There are 2 types of TLD, the GTLD, or the generic top-level, and CCTLD, or country code top-level domain. Historically, a GTLD was meant to tell the user the domain name's purpose. For example, a .com would be for a commercial purposes, or .org for an organization, .edu for education, and .gov for government. And a CCTLD was used for geographical purposes. For example, .ca for sites based in Canada, and .co.uk for sites based in the United Kingdom, and so on and so forth. Due to such demand, there is an influx of new GTLDs ranging from .online, .club, .biz, website, .biz, and many more. There's a whole bunch of them. If you've ever gone on Namecheap or GoDaddy or any domain registration site, you're going to see that there are new TLDs coming out. It seems like every single day at this point. For a full list, you can click there. I definitely recommend taking a brief look through them. There are some interesting ones, and it can give you an idea of, especially if you wanted to have your own website at some point, which is something that, for resume purposes, I highly recommend doing at the minimum. It's worth just taking a quick, half a minute look through there. Let's talk about the second level domain. Taking TryHackMe.com as an example, the .com part is the TLD, and TryHackMe is the second level domain. When registering a domain name, the second level domain is limited to 63 characters plus the TLD, and can only use A through Z and 0 through 9, and hyphens. It cannot start or end with hyphens or have consecutive hyphens, though. Next, let's talk about subdomains. A subdomain sits on the left-hand side of the second-level domain, using a period to separate it. For example, in the name admin.tryhackme.com, which I definitely recommend checking out if you haven't visited this before, the admin part is the subdomain. A subdomain name has the same creation restrictions as a second-level domain, being limited to 63 characters and can only use A through Z, 0 through 9, and hyphens, and of course the restrictions on hyphens still apply. You can use multiple subdomains split with periods to create longer names, such as jupiter.servers.tryhackme.com, but the maximum length must be kept below 253 characters. There is no limit to the number of subdomains you can create for your domain name. Now, subdomains, this is important to just know the structure. It comes into play a lot more as we start getting into websites and web hacking and things like that, especially when we're looking at cookies. Let's take a look at the questions below. What is the maximum length of a subdomain? I believe that was 63 characters, so we'll go ahead and submit that. Which of the following characters cannot be used in a subdomain? That's going to be the underscore. What is the maximum length of a domain name? That is going to be 253 characters. And then what type of TLD is .co.uk? This is going to be a CCTLD, or a country code top-level domain. All right, let's move into task 3, record types. DNS record types. DNS isn't just for websites though, and multiple types of domain or DNS records exist. We'll go over some of the most common ones you're likely to come across. First, we have the A record. This is the main one that you'll see, other than maybe pointer records, which we don't cover in here, but I'll briefly mention them after I go over the A record. These records resolve to IPv4 addresses. For example, you have this IPv4 address, so you'd have a domain name, and then it would resolve to that IP address. Pointer records go the other way, where you can go and have an IP and look up the domain that's associated with it. Very useful for reverse lookups. Then we have the quad A records. These records resolve to IPv4 addresses, and that's an example of an address there. Note there's some shortening here. Don't worry too much about this. You don't need to know too much about IPv6. Know it exists. Know that if it's on in the network, that's another way that you can explore and navigate around, but for all intents and purposes, with what we're doing right now, not too important. CNAME record, or canonical name. These records resolve to another domain name. For example, TryHackMe's online shop has the subdomain name store.tryhackme.com, which returns a CNAME record for shops.shopify.com. Another DNS request would then be made to shops.shopify.com to work out the specific IP address. So think of it this way. It's a way that we can relabel something, where we have a much more friendly name. In this case, we have the store.tryhackme.com, which is how we would remember it by, and that's how it's going to be linked on the TryHackMe website. And it's a Shopify domain, which has to be hosted on Shopify. I believe you can host it on your own. Don't worry too much about this, but it's a way that we can relabel it. It's a nice way that we can remember it, and it's much more friendly than trying to remember a Shopify domain. MX records, or mail exchange records. These records resolve to the address of the servers that handle the mail for your domain, or the domain you are querying. For example, an MX record response for tryhackme.com will look something like alt1.aspmx.l.google.com, and that's specifying in this case that this is a G Suite email server, and you'll learn a little bit more about these as you start examining them. Much more interesting if you are looking at this for example, phishing attacks, or if you're doing bug bounty and you're trying to identify the attack surface that's available. Knowing what MX servers are there can lead into other things. I won't go too far into that, but know that you'll be familiar with this eventually. These records also come with a priority flag. This tells the clients in which order to try the servers. This is perfect for if the main server goes down and email needs to be sent to a backup server. This happens, especially when you consider maintenance and updating and patching the mail exchange servers. And then last but not least, we have the TXT record, or text records. TXT records are free text fields where any text-based data can be stored. TXT records have multiple uses, but some common ones can be to list servers that have the authority to send an email on behalf of the domain. This can help in the battle against spam and spoofed email. They can also be used to verify ownership of the domain name when signing up for third-party services. Don't worry too much about this. This is something that if you get into web hosting, you'll learn a lot more about these. It's just important to know that they exist. What type of record will be used to advise where to send email? That will be an MX record. And then what type of record handles IPv6 addresses? That will be a quad A record. Let's move into task 4, making a request. What happens when you make a DNS request? First, when you request a domain name, your computer checks its local cache to see if you've previously looked up the address recently. If not, a request to your recursive DNS server will be made. 2. A recursive DNS server is usually provided by your ISP, Internet Service Provider, but you can also choose your own. This server has its own local cache of recently looked up domain names. If a result is found locally, this will be sent back to your computer, and your request ends here. This is common for popular and heavily requested services such as Google, Facebook, Twitter, YouTube. Anything that's going to be looked up a lot will probably live here. If the request cannot be found locally, a journey begins to find the correct answer, starting with the Internet's root DNS servers. Step 3. The root servers act as a DNS backbone of the Internet. Their job is to redirect you to the correct top-level domain server depending on your request. If, for example, you request www.tryhackme.com, the root server will recognize the top-level domain of .com and refer you to the correct TLD server that deals with .com addresses. And here we can see a diagram on the side that's walking through this request. So we have a computer making the request to the DNS server here. It says, hey, I don't have this stored locally in my cache, so we have to reach out the root DNS servers, and this is where we just ended off on. Then we have step 4. The TLD server holds records for where to find the authoritative server to answer the DNS request. The authoritative server is often known as the name server for the domain. For example, the name server for tryhackme.com is kip.ns.cloudflare.com, and we have a second one here as well. You'll often find multiple name servers for a domain name to act as a backup in case one goes down. So here we can see this has been sent over to try to find, hey, what name server actually holds these records? And you can see that we're drilling down through these servers in order to find a more fine-grained server that's responsible for what we're looking for. And then we have step 5. An authoritative DNS server is the server that is responsible for storing DNS records for a particular domain name and where any updates to your domain name DNS records would be made. Depending on the record type, the DNS record is then sent back to the recursive DNS server, where a local copy will be cached for future requests, and then relayed back to the original client that made the request in the first place. DNS records all come with a TTL, or time to live value. This value is a number represented in seconds that the response should be saved for locally until you have to look it up again. Caching saves on having to make a DNS request every time you communicate with the server. So here you can see in the diagram, we're sending this back to our recursive DNS server. So we say, hey, I have your answer here, or it just outright fails. And the DNS server here, assuming it's successful, will save that locally and then relay it back to the client. What field specifies how long a DNS record should be cached for? That's going to be the time to live, or TTL. What type of DNS server is usually provided by your ISP, or internet service provider? That is recursive. And what type of server holds all the records for a domain? That is going to be authoritative. And there we go. Let's move into task 5, practical. Using the website on the right, we can build requests to make DNS queries and view the results. Let's go ahead, we'll click on this, and we note that it's going to start spawning the website on the side. The website will also show you the command you need to run on your own computer if you wish to make the request. Hey everyone, welcome back to another video here on TryHackMe. TryHackMe. I'm John, and today we're going to be taking a look at the room HTTP in detail. Learn about how you request content from a web server using the HTTP protocol. And if you watched the DNS in detail room, I spoke a little bit to this previously. However, we don't have to worry about that too much quite yet. Let's go ahead and move into task. What is HTTP or HTTPS? What is HTTP? Hypertext Transfer Protocol. HTTP is what's used whenever you view a website. Developed by Tim Berners-Lee and his team between 1989 and 1981, HTTP is a set of rules used for communicating with web servers for the transmitting of web page data, whether it is HTML, images, videos, and so on and so forth. How about the secure version? HTTPS is the secure version of HTTP. HTTPS data is encrypted, so it not only stops people from seeing the data you are receiving and sending, but it also gives some assurances that you're talking to the correct web server and not something impersonating it, because there's a signature field there. Don't worry too much about that. Just know that there are systems built in there just to make sure that this is as safe as it can be. Answer the questions below. What does HTTP stand for? That stands for Hypertext Transfer. When we access a website, your browser will need to make requests to a web server for the assets such as HTML, images, and to download the responses. Before that, you need to tell the browser specifically how and where to access these resources. This is where URLs will help. What is a URL? Short for Uniform Resource Locator. If you've used the internet, you've used a URL before. A URL is predominantly an instruction on how to access a resource on the internet. The below image shows what a URL looks like with all of its features. It does not use all features in every single request, though. First, we have the scheme here at the start. This instructs on what protocol to use for accessing the resource, such as HTTP, HTTPS, FTP, and so on and so forth. We have the user, which is our user, and then we have a password here separated by colon. Some services require authentication to log in, and you can put a username and password into the URL to log in. Then we have the host, which is the domain name or IP address of the server you wish to access. That's going to be right here. We have the actual port that we're communicating on, which is what we're going to connect to. Usually this is going to be 80 for HTTP and 443 for the secure version, but this can be hosted on any port between 1 and 65,535, but traditionally this is going to be what they live on. Either that or 8080 is another common port to see, but we won't go too far into that. That's something that's a little bit more in the realm of CTFs. Then we have the path, which comes after this /, and that's the file name or location of the resource you're trying to access. We have the actual query string, which is the extra bits of information that can be sent to the requested path. For example, the blog, and then we have question mark, ID equals 1, would tell the blog path that you wish to receive the blog article with the ID of 1. And then we have the fragment. This is a reference to the location, and we can see it up here, on the actual page requested. This is commonly used for pages with long content and can have certain parts of the page directly linked to it, so it is viewable to the user as soon as they access the page. Don't worry too much about this, just know that we need to know this part primarily, as well as this part. Let's go into making the request. It is possible to make a request to a web server with just one line, get/http/1.1. So we have the request method right here with get, the page being requested, so the actual root, and then the protocol and the actual version there. But for a much richer web experience, you'll need to send other data as well. This other data is sent in what's called headers, where headers contain extra information to give the web server you're communicating with. But we'll go into this in a little bit more detail in the actual header task. And here we have an example request below, and here's a couple of those headers. To break down each line of this request, on line 1, this request is sending the get method, more on this in the HTTP methods task, request the homepage with the /, and telling the web server we are using the HTTP protocol version 1.1. Pretty common web request, pretty straightforward. On line 2, we tell the web server we want the website TryHackMe.com. We can see that right there with the host. And then on line 3, we tell the web server we are using Firefox version 87 for the web browser. This is our user agent. On line 5, we are telling the web server that the web page that referred us to this one is https://tryhackme.com. And then on line 5, it looks like it might not be there. Well, rather it is there. HTTP requests always end with a blank line to inform the web server that the request is finished. So it doesn't display right here, but there's an implied blank line. And here we have an example response. This is what's going to come back after we make that request. To break down each line of the response. Line 1, we have the version, and then we have our status code. In this case, it's 200 OK, which tells us the request is completed successfully. 200 is pretty common. 200s and 403s are going to be probably some of the most common codes that you see, along with 302. Don't worry too much about the other types of codes. We'll go into those a little bit later, I believe. Line 2, this tells us the web server software and version number. This won't always come back. Line 3 has the current date, time, and time zone of the web server. On line 4, the content type header tells the client what sort of information is going to be sent, such as HTML, images, videos, PDFs, XML, and so on and so forth. This just says, hey, I'm sending this is what you should expect. And then we have the actual link to the content that's enclosed, which is going to be on line 5. Line 6, the HTML response contains a blank line to confirm the end of the HTTP response, and then lines 7 through 14 has the actual information that we requested. So there's the website. Pretty straightforward here. What HTTP protocol is being used in the example above? That is going to be HTTP, and then /1.1. And there we go. What response header tells the browser how much data to expect? That is going to be what we saw on line 5 here, the content-length. And if you're interested in learning a little bit more about this, there is a web hacking technique called request smuggling. James Kettle, I believe, I might have just messed up his last name. He works with Portswigger, the people that make Burp Suite. He has a very, very well-done talk on content length and how you can mess with this, and how you can do a lot of really cool things. Again, that is request smuggling. I definitely recommend looking into it. If it goes a little bit over your head, don't worry about it. Just knowing about it is a good thing in the first place. That being said, let's move into task 3, HTTP methods. HTTP methods are a way for the client to show their intended action when making an HTTP request. There are a lot of HTTP methods, but we'll cover the most common ones, although mostly you'll deal with the get and post methods. First, we have the get request, which is used for getting information from the web server. It says, hey, I want this, and the web server will typically respond with, are you authorized for it? And it'll send it back. Then we have the post request. This is used for submitting data to the web server and potentially creating new records. So we're sending data to it. We have the put request, which is used for submitting data to a web server to update information. This is more situational, don't worry too much about this one. And then we have the delete request, which is used for deleting information and records from a web server. Again, more situational. The main ones you need to know are these two. What method will be used to create a new user account? That will be a post method. What method will be used to update your email address? For updates, it's going to be that put method. What method will be used to remove a picture you've uploaded to your account? That would be delete. What method will be used to view a news article? And that will be get. And there we go. Let's move into task 4, HTTP status codes. Let's go ahead and click on this so we can view the site. In the previous task, you've learned when an HTTP server responds. The first line always contains a status code informing the client of the outcome of their request and potentially how to handle it. These status codes can be broken down into 5 different ranges, and I recommend adding this to your notes if you're taking notes alongside of this. For now, I'm just going to go over an overview because this is really the important information. So the 100s are going to be an informational response. It'll tell you something about what comes back. Don't worry too much about this. These are not very common. This is the main one that you're going to see. The 200s are success. This can be success, but it'll have a little bit more information with it. So it might have a caveat of success, but maybe an update or something like that. 300s are going to be redirection, which means that the web server or the requested resource has been moved or to a different web page altogether. 400 is going to be, hey, you did something wrong on your end, there's a client error. And then 500s, which means that something broke on the server's end. If this ever happens, it's probably worth digging into, because these are interesting errors. Again, the main ones you're going to see are these. So client errors can range from things like something is actually malformed in the request to you don't have permission to access that. Again, very common. Common HTTP status codes. There are a lot of different HTTP status codes, and that's not including the fact that applications can even define their own. We'll go over the most common HTTP responses you are likely to come across. So first we have 200, which is okay, just means the request was completed successfully. Then we have 201, which is created, a resource has been created, for example, a new user or a new blog post. 301 is going to be a permanent redirect. This redirects the client's browser to a new web page or tells search engines that the page has been moved or somewhere else and to look there instead. Then we have 302, which is a temporary redirect, similar to the above permanent redirect, but as the name suggests, this is only a temporary change and may change again in the near future. Then we have 400s, which is an actual bad request, so that's where we get an actual malformed bit. This tells the browser that something was either wrong or missing in the request that was received. This could sometimes be used if the web server resource that is being requested expected a certain parameter and the client didn't send it. So, for example, with the blog, we requested the ID equals 1. What if we didn't include that ID? It might send back a, hey, what are you asking for with a 400? Next we have 401, which is the not authorized. You are not currently allowed to view this resource until you have authorized the web application, most commonly with a username and a password. Then we have 403, very, very similar to 401 because it's in that 400 category. You do not have permission to view this resource, whether you are logged in or not. 405, which is the method not allowed. This resource does not allow this method request. So for example, you send a get request to a resource for creating an account. When it was expecting a post request instead, it's going to say, hey, what are you doing? And it'll send back a 405 error. Next we have the 404 page request. The page/resource you requested does not exist. Then we have 500, the internal service error. This is a very interesting one. Keep an eye out for this one. The server has encountered some kind of error with your request, and it doesn't know how to handle it properly. This can usually be indicative of a deeper problem, or something has gone very wrong. And then we have 503, service unavailable. The server cannot handle your request as it's either overloaded or down for maintenance. I recommend taking this block along with the block above it and put those into your notes. Just really good to start memorizing, especially if you're going into web hacking. Click the view site button on the top right, which we've already done, to see some of these HTTP status messages in the browser. And we can see that we have a couple example ones here. So first we have 403, which is forbidden. 404, it's not there. And then 503, it's temporarily unavailable. What response code might you receive if you've created a new user or blog post article? That'll be 201, created. What response code might you receive if you tried to access a page that doesn't exist? That will be the good old 404 error. What response code might you receive if the web server cannot access its database and the application crashes? Not great. That should be, I believe, a 500 error. Maybe not. Let's see. Let's try 503 for that. And there we go. And what response code might you receive if you try to edit your profile without logging in first? That should be, I believe, a 401. Let's double check. Not authorized, so we need to log in. We'll go and submit that, and there we go. Let's move into task 5, headers. Headers are additional bits of data you can send to the the web server when making requests. Although no headers are strictly required when making an HTTP request, you'll find it difficult to view the website properly otherwise. Common request headers. These headers are sent from the client, usually a browser, to the server. First, we have the host header. Some web servers host multiple websites, so providing the host headers, by providing it, you can tell it which one you require. Otherwise, you'll just receive the default website for that server. Next, we have the user agent. This is your browser software and the version number. Telling the web server your browser software helps it format the website properly for your browser, and some elements of HTML, JavaScript, and CSS are only available in certain browsers. This mostly comes up when Internet Explorer, as much as it shouldn't exist still, gets in the mix. Internet Explorer doesn't support a lot of things and isn't very well kept up. If you look up Internet Explorer compatibility issues, you should find plenty of them. Just look through that, it'll give you a good idea of why this is really important. Next, we have content length. I talk about this quite a bit. It's going to be the length of the actual data that is in there, and this is done as a way to ensure that it's not missing any data, so that the entire request was actually received, or response in that case. And then accept encoding. This tells the web server what types of compression methods the browser supports, so the data can be made smaller for transmitting over the internet. And then last but not least, we have cookies, which is the data sent to the server to help you remember your information. See the cookies task for more information on this, and we'll talk about this a little bit more later. Common response headers. These are headers that are returned to the client from the server after a request. First, we have the sent cookie header, information to store which gets sent back to the web server on each request. Again, we're going to talk about this a little bit later on. Think of this as sort of your hall pass or your authentication card. You present it every single time you go through the door, and it says, hey, this is valid, it gets checked by the server, hopefully, and it's a way to authenticate. Cache control, how long to store the content of the response in the browser's cache before it requests it again. This saves on bandwidth and was much more important in the early days of the internet. Not a big deal at this point, but it still saves a bunch of data. Content type, this tells the client what type of data is being returned. We talked about this already in a previous task. This can be a source of error. Don't worry about this too much right now, but this is something that as you get into web hacking, you will become very much more used to, because you can do a lot of bad things with that. And then content encoding. What method has been used to compress the data to make it smaller when sending it over the internet? Answer the questions below. What header tells the web server what browser is being used? That is going to be our client, or user agent rather. So user-agent. And what header tells the browser what type of data is being returned? That is going to be the content type. And what header tells the web server which website is being requested? That is going to be the host header. And there we go. Let's move into task 6, cookies. Let's go ahead and click on the View Site button. You've probably heard of cookies before. They're just a small piece of data that is stored on your computer, ironically in a spot that's named the cookie jar. That is a real thing and is something that your browser uses. Cookies are saved when you receive a set cookie header from the web server. Then every further request you make, you'll send the cookie back to the website server. This is a little bit finer grained detail, and you'll get into this when you start learning about the finer ins and outs of cookies, but generally speaking, it'll be sent back to in every request to that same website, as long as it matches. Because HTTP is stateless and it doesn't keep track of your previous request, cookies can be used to remind the web server who you are, some personal settings for the website, or whether you've been to the website before. Let's take a look at this as an example HTTP request. So here we can see that we have a GET request, and we have just our basic headers here, and we can see that we have our response and a little bit of data. We are going to post a little bit more data, which is our actual login here. So we're logging into the website, and we have our cookie being returned. It says, hey, you've logged in. Here's a cookie. Put it in your cookie jar. Send it back whenever you're making another request, because it says, hey, you are still logged in. And here we can see that we're doing exactly that, where we're making a request to the website, and we send our cookie along. And the website responds saying, hey, welcome back. You're logged in. You clearly have authenticated because you sent the cookie. Cookies can be used for many purposes, but most commonly are used for website authentication. The cookie value won't usually be a clear text string where you can see the password, but rather this will be a token, a unique secret code that isn't easily human guessable. And if you ever want an example of this, take a look at your web browser's cookies. You can download an extension that's like Cookie Editor or things like that for Chrome, and you can play around with it a little bit there. And even then, we're going to talk about how to view your cookies here. Now we have viewing your cookies. Just to digress on the topic I just touched on, you can easily view what cookies your browser is sending to a website by using the developer tools in your browser. If you're not sure how to get the developer tools in your browser, click on the View Site button on the top of this task for a guide. So here we can see that we have a guide here. And this will show how to actually get it with Firefox. And it looks like just Firefox, but pretty straightforward. Once you have developer tools open, click on the Network tab. This tab will show you a list of all the resources your browser has requested. You can click on each one to receive a detailed breakdown of the request and response. If your browser sent a cookie, you will see these on the Cookies tab of the request. Let's take a look at the question here. Which header is used to save cookies to your computer? That is going to be the set cookie header. As long as I typed it correctly. And there we go. Let's go ahead and move into task 7, making requests. We'll go ahead and click on the View Site button there. This is an emulator for making demo HTTP requests. video here on TryHackMe. I'm John, and today we're going to take a look at the room How Websites Work. To exploit a website, you first need to know how they are created. Let's go ahead and dive into Task 1, How Websites Work. By the end of this room, you'll know how some websites are created, and we'll be introduced to some basic security issues. When you visit a website, your browser, like Safari or Google Chrome or Firefox, pick your poison there, makes a request to a web server asking for information about the page you're visiting. It will respond with data that your browser uses to show the page. A web server is just a dedicated computer somewhere else in the world that handles your request. So we are sending a request saying, hey, can I get this website or get the page that is on this website? And the web server will send back that information, or it'll say, hold on, I can't do anything with an error code or something like that. Let's go ahead and dive in here, though. And here we can see a nice diagram where we have us on our browser that we are making the request from the browser, goes over the magical, wonderful fairy cloud that is the internet, and then we can see it emerges on the other side where the web server lives. The web server will respond with the appropriate code, rather. Typically, this is going to be 200. Don't worry too much about that right now, but it's going to have the content of the web page, generally speaking. And this goes back over the internet, back to our web browser, which can interpret that and render the web page, which is what we actually see here. There are two major components that make up a website. First, we have the front end, or the client side, the way your browser renders a website. This is what we actually see. And the back end, which is server side, a server that processes your request and returns a response. There are many other processes involved in your browser making a request to a web server, but for now, you just need to understand that you need to make a request to a server, and it responds with data your browser uses to render information to you. So, a little bit of a back and forth pattern there. What term describes the way your browser renders a website? That is going to be the front end. And there we go. Let's move into Task 2, HTML. Websites are primarily created using HTML, which is to build websites and define their structure, CSS or cascading style sheets to make websites look pretty by adding styling options, and then JavaScript, which implements the complex features on pages using interactivity. Hypertext Markup Language, or HTML for short, is a language websites are written in. Elements, also known as tags, are the building blocks of HTML pages, and they tell the browser how to display the content. It's sort of like a map that tells the browser, hey, this goes up in this spot, it needs to go above this other thing, or where it can get things like images and other things like that. The code snippet below shows a simple HTML document, the structure of which is the same for every website, where we can see that we have the doc type declared up the top, along with some other interesting details that we'll go over in just a moment. The HTML structure, as shown in the screenshot, has the following components. The doc type HTML defines that the page is an HTML5 document. This helps the standardization across different browsers and tells the browser to use HTML5 to interpret the page. The HTML element is the root element of the HTML page. All other elements come after this element. So think of it this way. We need to have HTML here at the start and then a closing tag at the bottom. It is a sandwich that holds everything else in because, in order to make a sandwich, if you're making a normal sandwich, that is, you need to have a slice of bread on the top and a slice of bread on the bottom. Everything else is kind of in an order, but we'll see how that devolves in the case of this website. Next, we have the head element, which contains information about the page, such as the page title. And we can see that's right up here with this title tag. And that would be the example of something that would be on top. The body element is the next one, which defines the HTML document's body. Only content inside the body is shown in the browser. So this is where your actual content of the website would be. So, for example, let's talk YouTube. The player is going to be in the body of that. That's because it's what renders and what we see on this web page. The H1 element defines a large heading. This can go from 1 to, I believe, 6, if not a little bit further, where the 1 is the biggest one, and as you increment that, it gets a little bit smaller. And then we have the P element, which defines a paragraph. That can just be a bunch of text on the website. This doesn't necessarily have to be a proper paragraph like you were probably taught in English class. However, this is something that it just says, hey, there's a bunch of text here. There are many other elements, tags, used for different purposes. For example, there are tags for buttons, so we have the button tag there, images, IMG, lists, and much more. Tags can contain attributes, such as the class attribute, which can be used to style an element. So, for example, we would use it to make it a different color. So we have this paragraph, which its class is bold text, or the source element, or attribute rather, which is used on images to specify the location of the actual image. So here we can see with this image tag, we have our source, and then actually says, hey, within the actual web server, we need to go into the image folder, and then we're going to grab cat.jpg. An element can have multiple attributes, each with its own unique purpose. So, for example, we have paragraph, attribute 1, value 1, and so on and so forth. This is just useful for whenever we need to actually call or navigate this document, or what's called the DOM, within either our styling with the CSS or further on within the JavaScript. Elements can also have an ID attribute, so we have the ID equals example here in that paragraph tag, which is unique to the element. Unlike the class attribute, where multiple elements can use the same class, an element must have different IDs to identify them uniquely. Element IDs are used for styling and to identify it by JavaScript. As I mentioned a little bit beforehand, think of it as that's how we can call out to specifically what we want to interact with. You can view the HTML of any website by right-clicking and selecting View Page Source in Chrome or View Page Source in Safari. Let's go ahead and take a look at the questions. Let's play with some HTML. On the right-hand side, you should see a box that renders HTML. If you enter some HTML into the box and click the green Render HTML Code button, it will render your HTML on the page, and you should see an image of some cats. And here we can see, if we scroll down, sure enough, we have a cat. We'll go ahead and mark that as completed. One of the images on the cat website is broken. Fix it. and the image will reveal the hidden text answer. So it looks like we are missing our .jpeg here. And then we can go and click render that, and there we go. And we We have our flag, HTML, hero. Script. JavaScript, or JS for short, is one of the most popular coding languages in the world and allows pages to become interactive. HTML is used to create the website structure and content, while JavaScript is used to control the functionality of web pages. Without JavaScript, a page would not have interactive elements and would always be static. JavaScript can dynamically update the page in real time, giving functionality to change the style of a button when a particular event on the page occurs, such as when a user clicks a button, or to display moving animations. And before we move on, I'm going to go ahead and click this button so the site on the side can change to what we need for this activity. JavaScript is added within the page source code and can be either loaded within script tags or be included remotely with the src attribute. And here we can see that we have an example of that script tag where we're specifying a source for that JavaScript file. The following JavaScript code finds an HTML element on the page with the ID of demo. It changes the element's contents to hack the planet. And here we can see that we're navigating this document that we had. So document.getElementById, and then we're specifying the ID that we're looking for is demo. And don't forget, this ID attribute needs to be unique. And then inside that HTML of that specific item, we're changing it to hack the planet. And note, because this is a string, don't worry too much about this right now. If this is sounding confusing, because this is a string, it needs to be enclosed in quotes. HTML elements can also have events, such as onClick or onHover, that execute JavaScript when the event occurs. The following code changes the text of an element with the demo ID to button clicked. And here we can see we have our tag for our button, and then we have specified onClick document.getElementById demo, again because we're trying to get that demo specific item, and then the HTML in there, we're going to change it to button clicked. And then we have a text for the actual button of click me. OnClick events can also be defined inside the JavaScript script tags and not on the elements directly. Answer the questions below. Click the View Site button on this task. On the right-hand side, add JavaScript that changes the demo element's content to hack the planet. And it looks like we have a spot for JavaScript right there. Let's go ahead and we can scroll up and we can see the actual example here. So we already have script tags, don't have to worry about that. And we can do document.getElementBy ID, and note this is case sensitive, so if something isn't working, be sure to check that everything is cased out correctly. You can also copy this directly over if you'd like. And then we're looking for the demo element, and then inner HTML, since we want to change what the HTML is right here, and we can change that to hack the planet. And there we go. And we typically, because this is JavaScript, we need to have a semicolon at the end. And there we go. So we have our pop-up here. This is a little bit hard to read on my screen, but it's JS is fun in all caps. And I'll type that. Out here. JS is fun. And there we go. Add the button HTML from this task that changes the element's text to button clicked on the editor on the right. Update the code by clicking render HTML plus JS code button, and then click the actual button. That was quite a bit there. Let's go ahead and copy this over, and we can add just below this the actual button. don't necessarily need that again, but now I have this task 5 occurs when a website doesn't properly protect or remove sensitive clear text information to the end user. Usually this is found in the site's front-end source code. We now know that websites are built using many HTML elements or tags, all of which we can see simply by viewing the page source. A website developer may have forgotten to remove web or login credentials, hidden links to private parts of the website, or other sensitive data shown in HTML or JavaScript. And here we can see that this is a comment in the actual HTML document itself that has credentials. This is very common to see, especially as you're getting into beginner pen testing boxes. You will see that this happens, and it's always worth taking a look at the source code of a website, especially if you're doing something like bug bounty. You never know what you're going to find, and it more than often is pretty interesting. Sensitive information can be potentially leveraged to further an attacker's access within different parts of a web application. For example, there could be HTML comments with temporary login credentials, and if you viewed the page's source code and found this, you could use those credentials to log in elsewhere in the application, or worse, use to access the backend components of the site. That would not be good if we could get to a database or something like that. Whenever you're accessing a web application or assessing a web application for security issues, one of the first things you should do is review the page source code to see if you can find any exposed login credentials or hidden links. View the website in this task. What is the password hidden in the source code? So let's go ahead, let's try logging in with admin, and then we'll do admin. And if we click login, it looks like that's not going to work. Let's go ahead and click on this, and we can pull up the source code. And this is a little bit small. Let's make this a bit bigger. And it looks like, sure enough, there is a comment block. here with test, and congratulations. Click the View Site button. HTML injection is a vulnerability that occurs when unfiltered user input is displayed on the page. If a website fails to sanitize user input, so filter any malicious text that a user inputs into a website, and that input is displayed on the page, an attacker can inject HTML code into a vulnerable website. If this doesn't make a ton of sense, think of it this way: we can essentially add our own code and potentially do a lot of bad with this, from remote code execution to cross-site scripting or other things like that. If this is going over your head right now, don't worry too much about it. Just know that if we can add code to a website as an end user, that's very bad. Input sanitization is very important in keeping a website secure, as front-end or as information a user inputs into a website is often used in other front-end and back-end functionality. A vulnerability you'll explore in another lab is database injection, where you can manipulate a database lookup query to log in as another user by controlling the input that's directly used in the query. But for now, let's focus on HTML injection, which is client-side. That means it's going to show up on our actual page. When a user has control of how their input is displayed, they can submit HTML or JavaScript code, and the browser will use it on the page, allowing the user to control the page's appearance and functionality. So here we can see that we have an input field here, and we can see that it's going into this JavaScript function, and it's returning back that name up here. That's not good, because this is not sanitized. We're not checking to see if, the person that's putting this in here has bad intentions and is entering something that's kind of dangerous. The image above shows how a form outputs text to the page. Whatever the user inputs into the what's your name field is passed to a JavaScript function and output to the page, which means if the user adds their own HTML or JavaScript in the field, it's used to say in the say hi function and is added to the page, which means you can add your own HTML, such as an h1 tag, and it will output your input as pure HTML. Try saying that 10 times fast. The general rule is to never trust user input. It doesn't matter if you think your users are all wonderful people and they're going to put in, nothing bad. You have to operate on a model of sanitize anything that comes in. It has to happen. If it's not there, you're going to have a bad day. To prevent malicious input, the website developer should sanitize everything the user enters before using it in the JavaScript function. In this case, the developer could remove any HTML tags. Answer the questions below. View the website on this task and inject HTML so a malicious link to http://hacker.com is shown. So let's try, let me just put in my name, and we can see that it's reflected back up here. And if I go and, let's see, we'll do an @ so this is the HTML code for an actual link, and we want to do, let's see, href equals http hacker.com. Don't worry too much if this is a little bit over your head right now. And we're going to put this inside here just for funsies. So that's the actual text that will be displayed, and then we need to close out our link tag. And I'll scroll back through this just so you can see everything that's here. Pretty straightforward. So we're just adding in a link to the web page, and then we're specifying, hey, I want you to go here. And there we go. And there we go. That's going to be our answer, and we have our flag HTML_injection, and we'll go ahead and a link to the web page, and then we're equals http hacker.com. Don't worry too much if this is a little bit over your head right now. And we're going to put this inside here just for funsies. So that's the actual text that will be displayed. And then we need to close out our link tag. And I'll scroll back through this just so you can. see everything that's here. Pretty straightforward. So we're just adding in a link to the web page, and then we're specifying, hey, I want you to go here. And there we go. And there we go. That's going to be our answer, and we have our flag HTML_injection, and we'll go ahead and copy that. That's a bit hard to read, and it looks like some of the letters are changed out for numbers. So the E is a 3, and then the O is a 0. And there we go. That's going to do it for this room. As always, if you have any questions, the TryHackMe Discord and the subreddit will be linked in the video description. Hey everyone, welcome back to another video here on TryHackMe. I'm John, and today we'll be taking a look at the room, putting it all together. Learn how all the individual components of the web work together to bring you access to your favorite websites. Let's dive into task 1, putting it all together. From the previous modules, you've learned quite a lot of things that go on behind the scenes when you make a request to a web page in your browser. To summarize, when you request a website, your computer needs to know the server's IP address it needs to talk to, and for this, it uses DNS, or the domain name system. Your computer then talks to the web server using a special set of commands called the HTTP protocol, and then the web server returns HTML, JavaScript, CSS, images, and so on and so forth, which your browser uses to correctly format and display the website to you. And here we can see that we have the request here. We are finding the actual IP with DNS, we connect to the actual web server that we want to talk to, and then we can view the website, which sent back the information to us. There are also a few other components that help the web run more efficiently and provide extra features. We'll go ahead and mark this as completed and move into task 2, other components. We'll go ahead and close that. First, we have load balancers. When a website's traffic starts getting quite large, or is running an application that needs to have high availability, one web server might be no longer enough to do the job. Load balancers provide two main features, ensuring high-traffic websites can handle the load and providing a failover if a server becomes unresponsive. This happens a lot, and that's something that, especially if you get into web dev, you're going to start seeing that high availability is very important. When you request a website with a load balancer, the load balancer will receive your request first and then forward it to one of the multiple servers behind it. The load balancer uses different algorithms to decide which server is best to deal with the request. A couple of examples of these algorithms are round robin, which sends it to each server in turn, or weighted, which checks how many requests a server is currently dealing with and sends it to the least busy server. Load balancers also perform periodic checks with each server to ensure that they are running correctly. This is called a health check, and this is often referred to as a heartbeat to make sure that it's still running. That's something that if you ever get into VMware or virtual machines on an enterprise scale, you'll see a lot of that come up, especially with AWS as well. If a server doesn't respond appropriately or doesn't respond at all, the load balancer will stop sending traffic until it responds appropriately again. Next we have CDNs, or content delivery networks. A CDN can be an excellent resource for cutting down traffic to a busy website. It allows you to host static files from your website, such as JavaScript, CSS, images, videos, and so on and so forth, and host them across thousands of servers all over the world. When a user requests one of the hosted files, the CDN works out where the nearest server is physically located and sends the request there instead of potentially the other side of the world, because that's going to take a lot longer. Even though the internet's pretty fast, that's still a long time for the request. If you want a really good example of this, Amazon's CloudFront is a CDN, and I believe Netflix leverages that. Think of it for Netflix's videos. This is how it knows to send you to a server that's near you, so if you are right next to London in the UK, you will have your request sent to London, a data farm there, rather than somewhere else, maybe in the United States. Next we have databases. Often websites will need a way of storing information for their users. Websites can communicate with databases to store and recall data from them. Databases can range from just a simple plain text file up to complex clusters of multiple servers, providing speed and resilience. You'll come across some common databases such as MySQL, MS SQL or Microsoft SQL, MongoDB, GraphQL, Postgres, and many more. Each has its own specific features, and it's really meant for a specific type of application. Next we have WAFs, or Web Application Firewalls. A WAF sits between your web request and a web server. Its primary purpose is to protect the web server from hacking or denial of service attacks. A good example of this is actually Cloudflare. It analyzes the web request for common attack techniques, whether the request is from a real browser rather than a bot, and it will also check if an excessive amount of web requests are being sent by utilizing something called rate limiting, which will only allow a certain amount of requests from an IP per second. If a request is deemed a potential attack, it will be dropped and never sent to the web server. Let's take a look at the questions below. What can be used to host static files and speed up clients that visit a website? That is a CDN, or a content delivery network. What does a load balancer perform to make sure a host is still alive? That is a health, let's see, I believe it's health check specifically in this case. There we go. What can be used to help against the hacking of a website? That is a WAF, or a Web Application Firewall. Let's move into task 3, how web servers work. What is a web server? A web server is a software that listens for incoming connections and then utilizes the HTTP protocol to deliver web content to its clients. The most common web software or web server software you'll come across is Apache, Nginx, IIS, or oh my goodness, I can't remember the what that expands to. This is the Microsoft web server. This is something that if you have a Windows server, you will see this as an install option, and then Node.js. A web server delivers files from what's called its root directory, which is defined in the software settings. So for example, Nginx and Apache share the same default location of var www/html, common location to end up in if you're doing web hacking and get a shell on the server in Linux operating systems. And IIS uses /inetpub/www root for the Windows operating systems. So for example, if you requested the file http and it looks like we're looking for a picture.jpg file, it would send the file var www picture.jpg from its local hard drive. And this just specifies, since we don't have any other folders at the end of the actual domain, this is from the root of the web server. Next we have virtual hosts. Web servers can host multiple websites, and that's very common, with different domain names. To achieve this, they use virtual hosts. The server software checks the host name being requested from the HTTP header and matches that against its virtual host. Virtual hosts are just text-based configuration files. If it finds a match, the correct website will be provided. If no match is found, the default website will be provided instead. Virtual hosts can have their root directory mapped to different locations on the hard drive. For example, 1.com being mapped to var www website_1, and 2 being mapped to var www website_2. There's no limit to the number of websites you can host on a web server, other than performance. If you start hosting too many, it might come to a crawl. Static versus dynamic content. Static content, as the name suggests, is content that never changes. Common examples of this are pictures, JavaScript, CSS, and so on and so forth, but can also include HTML that never changes. For example, or furthermore, these are files that are directly served from the web server with no changes made to them. Dynamic content, on the other hand, is content that could change with different requests. Take, for example, a blog. On the homepage of the blog, it will show you the latest entries. If a new entry is created, the homepage is then updated with the latest entry. Or a second example might be a search page on a blog. Depending on what words you search for, different results will be displayed. These change what you end up seeing, and what are done in the backend is these changes to what you end up seeing are done in what is called the backend, with the use of programming and scripting languages. It's called the backend because what is done is all behind the scenes, and this happens outside of what we would actually see on the front end, which is the client side. You can't view the website's HTML source and see what's happening in the backend, while the HTML is the result of processing from the backend. Everything you see in your browser is called the front end. Scripting and backend languages. There's not much of a limit to what a backend language can achieve, and these are what make a website interactive to the user. Some examples of these languages, in no particular order, are PHP, Python, Ruby, Node.js, Perl, and many more. These languages can interact with databases, call external services, process data from the user, and so much more. A basic PHP example of this would be if you requested the website example.com/index.php with a parameter of name equals Adam. If index.php was built like this, so we're looking for the parameter on the GET request for name, and we can see that up here, we're going to go ahead and have hello and then the actual name reflected back to the client, and we can see that right here. You'll notice that the client doesn't see any PHP code because it's on the back end. This interactivity opens up a lot more security issues for web applications that haven't been created securely, as you'll learn in further modules. What does web server software used to host multiple sites? That is virtual hosts. What is a name for the content that can change rather? That is dynamic. Does the client see the backend code? And that is going to be nay. We do not see the backend code. Let's move into the final task, task 4, quiz. Click the view site button on the right. We'll go ahead and get that, and we can close out of that. And then using everything you've learned from the other modules, drag and drop the tiles into the correct order of how a request works to reveal the flag. Note when placing a title in the correct position, it will highlight in green. When a tile is in the wrong spot, it will highlight in red. Make sure not to refresh the page, as it will reset the tiles to blank again. Let's see. So the first thing that we want to do, and we can actually make this a little bit easier on ourselves, and go up to the first task. And we can see that we've got some hints here. So let's see. We have the request in your web browser, and that should be number 1. So we're making that request. And then next, this is going to go to the recursive DNS server for checking for that address. Actually, that might be later on. Let me go ahead and, let's see. Should check our local cache first. I'm going to go ahead and pause. I'll put these all in order, and we'll be right back. All right, and we're back. So let's go ahead and walk through this process, and we'll go ahead and open this up. First, we have our request to TryHackMe.com in the browser. It's going to check our local cache for the IP address to see if we've already made this recently, because why send the request if we don't need to? Next, if it's not found locally, it'll check our recursive DNS server for the address. The DNS server will then query the root server to find the authoritative DNS server. The authoritative DNS server advises the IP for the website, then the actual request that we've sent, passes through the web application firewall, and then it passes to a load balancer, and then it'll finally connect to the website on port 80 or 443. Next, the web server receives the GET request. The web server itself, or the web application, is going to talk to its database to see if there's anything that it needs for like dynamic content or if you're authenticating, and then the request is sent back to your browser, which will render the HTML into a viewable website. After completing this, you should get a little pop-up, and that'll have your flag. I'll go ahead and put that down there. And there we go. That's going to do it for this room. If you have any questions, as always, the TryHackMe Discord and the subreddit will be linked in the video description below. But until next time, happy hacking! Hey everyone, welcome back to another video here on TryHackMe. I am John. Learn to run some of the first essential commands on an interactive terminal. Now, if you have had very little experience with Linux, or maybe none at all, you're in the right place. Maybe the command line is kind of a spooky thing that, maybe you're not very comfortable with it. Or maybe you've had some practice and you want to polish things up and get additional practice to really solidify those Linux skills. If so, you are in the right place. Today we're going to be going through the first part of the Linux Fundamentals series, and I recommend going through all three of them, and these are really going to help solidify your Linux skills into making you a professional. That being said, let's go ahead and dive right into Task 1, Introduction. Welcome to the first part of Linux Fundamentals Room Series. You're most likely using a Windows or a Mac machine. Both are different in visual design and how they operate. Just like Windows, iOS, and macOS, Linux is just another operating system and one of the most popular in the world, powering smart cars, Android devices, supercomputers, home appliances, enterprise servers, and more. Linux is kind of everywhere, and yes, a bunch of things such as Android are just Linux under the hood. A lot of game consoles are actually just Linux under the hood because Linux can be trimmed down pretty heavily and customized very, very heavily as well. We'll briefly touch on that throughout the room just to give you some background knowledge. That being said, let's go ahead and continue. We'll be covering some of the history behind Linux, and then eventually starting your journey of being a Linux wizard. This room will have you running your very first commands in an interactive Linux machine in your browser, teaching you some essential commands used to interact with the file system, and it will introduce you to how users and groups work on Linux, and what that means for us as penetration testers, or just security professionals in general. Let's go ahead and mark this as completed, and move into Task 2, a bit of background on Linux. Where is Linux used? It's fair to say that Linux is a lot more intimidating to approach than operating systems such as Windows. Both variants have their own advantages and disadvantages. For example, Linux is considerably much more lightweight, and you'd be surprised to know that there's a good chance you use Linux in some form or another every day. Linux powers things such as websites you visit. Most websites are hosted on Linux servers with Apache or another server that's running them. Car entertainment, control panels, a lot of those will run stripped down versions of Android or Linux as an embedded system. Point of sale systems such as checkout tills and registers in shops. Yep, very common for those to be Linux. Critical infrastructures such as traffic light controllers or industrial sensors. A lot of times those will be very heavily trimmed down versions of Linux such as Alpine or something even thinner. That's definitely something that I recommend looking into, just traffic controllers and things like that. It's very interesting because those are controlled by just basic operating systems like Linux. Let's talk about the flavors of Linux rather. The name Linux is actually an umbrella term for multiple OSs that are based on the Unix, another operating system. Unix is the, I guess, overarching flavor for how the operating system is designed, and Linux is multiple like flavors of operating systems that fit under that. When we say flavors, there are many different styles of Linux with little different tweaks, ways that they function, different package managers. Don't worry about knowing this right now, just have a general background knowledge that there's a bunch of different kinds of Linux. Thanks to Unix being open source, variants of Linux come in all shapes and sizes, suited best for what the system is being used for. For example, Ubuntu and Debian are some of the more commonplace distributions of Linux because they're really extensible. So for example, you can run Ubuntu as a server, such as for websites or web applications, or as a fully fledged desktop. You can install a GUI on that. Even if you're starting with a server installation of the operating system, you can install the actual user interface and give yourself that GUI. For this series, we're going to be using Ubuntu, which is really common. If you've ever run maybe a Minecraft server or something like that, you've probably used Ubuntu in that specific case. Ubuntu server can run on systems with only half a gig of RAM. Not a lot of RAM there. Similar to how you have different versions of Windows, 7, 8, and 10, for example, there are many different versions and distributions of Linux. So the next part is a little bit of research. What year was the first release of a Linux operating system? I'm going to pause here for just a moment. If you want to look this up yourself, feel free to search for it now. Otherwise, I'm going to go ahead and give you the answer. The answer to this is 1991. That is when the first release of Linux took place. Let's move on to task 3, interacting with your first Linux machine in browser. This room has an Ubuntu Linux machine that you can interact with all within your browser whilst following along with this room's material. However, to get started, simply press the green Start Machine button just right over here on the top right of this task, indicated by the arrow to the right. Let's go ahead and press that now, and we'll let this start loading. And you can see that we have this card with active machine information. So the first one over here is the title. That's just useful to know what's running. Don't worry too much about this. It's not very important. Then we have the IP address. This is how we're going to interact with the machine for the most part. This is how we know what machine we're going to. Think of it, if you're not familiar with with IP addresses, think of this as like the street address that we've given the machine. And then we have the expiration timer. All these machines spawn with a default of 2 hours for their time. However, we can extend that if it falls under an hour, and we can also terminate it early if we're done with the machine. All right, let's move in over here. So we can see that this is a basic overview of what I just covered, and at some point we will have this pop up with the terminal. Let's go ahead and mark this as completed, and we will move into task 4 while this is still loading. As we previously discussed, a large selling point of using operating system Systems such as Ubuntu is how lightweight they can be. This, of course, doesn't come without its disadvantages, where, for example, often there is no GUI, so graphical user interface, or what is known as a desktop environment, that we can use to interact with the machine unless it has been installed. So again, if you have something that's just a command line, which we're going to see over here, you can install a desktop if you really wanted to. That being said, a lot of time system administrators will opt to just use the command line, just because it's as powerful as using the desktop, and for most things, it's a lot faster. A large part of interacting with these systems is using the terminal, which we're going to see here in just a moment. The terminal is purely text-based and is intimidating at first. However, if we break down some of the commands, after some time, you will quickly become familiar with interacting with the device. And you can see an example of the terminal here, and I'll demo it here in just a moment. We need to be able to do basic functions like navigate to files, output their contents, and make files. The commands to do so are self-explanatory, once you know what they are, of course. That being said, real quick meta note on that. As far as these commands go, I do recommend taking notes on these commands. It'll make it easier to pick them up with practice as well. Additionally, I recommend learning what these commands are short for. A lot of them are abbreviations. So for example, who am I? If you read that out, pretty self-explanatory. We're trying to figure out what user we're logged in as, and so on and so forth. As I go throughout these rooms, all three of them in this series, I will read out how I remember them or what they stand for, and so on and so forth. That being said, we're going to cover these two commands in this task. So the first one here is echo. So echo is as it sounds. We're saying something, or we're asking for something, and we want the terminal to repeat it back to us. It's like saying something into a cave, you hear it come back. And we can see in this case that if we type echo, and it's within a grand scheme of right now, that's just to give you an idea of what we would actually use this for with practice. So the user we're logged in, command B. That would be echo, and then try hack me. Note, if we don't have spaces here in the actual text that we want to have echoed, logged in as on your deployment, you can do that to submit the answer to the question, and that way you don't have to click correct answer, or click submit rather. Let's go ahead and move into task 5, interacting with the file system. So far we've only covered the echo and who am I commands. Not all that useful when you consider the things that we need to do, including navigating the file system, read and write to it as well. In this task, we're going to be learning the commands so that we can do just that. Just like the previous task, I'll display the commands in the table in the heading down here, and some show examples of these commands being used. I'm going to go ahead and go past this. I do recommend taking notes on that. However, I'm going to go through and break down the commands one by one. Listing files in our current directory with ls. Before we can do anything such as finding out the contents of any files or folders, we need to know what exists in the first place. This can be done using the ls command, short for listing. And we can see a nice demo of it down here, where you can see that the Ubuntu user in this case has run ls, and we can see that it looks like we have a couple directories here. In the screenshot above, we can see there are the following directories and folders, and I won't go through that. You can see them right up there. Great, you can probably take a guess as what to expect a folder to contain given by its name. And that's very common. This is the same as what you would see in a Windows computer, where if you're in your user's home directory, in Windows or in OS X, you can see that you have like a pictures folder, a music folder, and so on and so forth. Pro tip, you can list the contents of a directory without having to navigate to it by using ls and the name of the directory. So for example, if I do ls, we can see that we have a whole bunch of different things, and I do ls folder 1, and I want to trim off that end. There we go. We can see that there's nothing in it, so a bit of a bad example, but you can see that we could list what was in it, if anything. Changing our current directory with cd. Now that we know what folders exist, we need to use the cd command, short for change directory, to change to that directory. Say if I wanted to open the pictures directory, I'd do the cd pictures, where again, we want to find out the contents of the picture directory, and to do so, we would use ls once we've actually moved in there. Let's demo that real quick. So let's see, we will cd to folder 2, and then ls, and we can see that there's nothing in folder 2, but we can go back up a directory by doing ... That means return to the previous directory. Oh, there we go. And we can see in this example, we have moved into this directory and there are a bunch of pictures of dogs. I'll put in the contents of a file with cat. And let me go ahead, I'm going to clear my terminal on the right hand side. This is done with Control and L, so I'm holding down Control and then hitting L, and that clears the screen. Pretty nice. Whilst knowing about the existence of files is great, it's not all that useful unless we're able to view the contents of them. We will come back to discuss some of the tools available to us that allows us to transfer files from one machine to another in a later room, but for now, we're going to talk about simply seeing the contents of text files using a command called cat. Cat is short for concatenating. It is a fantastic way to output the contents of files, not just text files. Actually, cat will, even if you have binary files, so think like executables on Windows or things that you would run, it will do its best effort to display everything in that file. You'll get a lot of random, just garbage text, but you can definitely see what's in the file. So just something to be aware of. In the screenshot below, you can see how I have combined the use of ls to list the files within a directory called documents with cat right over here. So we've listed the files, and then we've used cat on this file to list out what's in it. We've applied some knowledge from an earlier task to do the following. We've used ls to let us know what files are in the documents folder of this machine. In this case, it's called todo.txt. And then we have then used cat and then todo.txt to concatenate/output the contents of this todo.txt file. Where the contents are, here's something important for me to do later. Pro tip, you can use cat to output the contents of a file, so you don't actually have to navigate to that file. You can use what's called the absolute path. Don't worry too much about this right now, but this is the full path from the root of the file system, which we'll cover later, to the actual file itself. Sometimes things like usernames, passwords, yes, really, this does happen a lot. You'd be surprised what you can find. It's the equivalent of finding sticky notes on people's desks, and it happens a lot. Flags or configuration settings are stored within files where cat can be used to retrieve these. Cat will be your best friend, and trust me, you will be familiar with that command in no time flat. Finding out the full path to our current working directory with pwd. You'll notice as you progress through your navigating your Linux machine that the name of the directory you're currently working in will be listed in your terminal. So in this case, it's not listed right now, but if I were to cd into folder 1, we can see that it's listed right here at the start. So we are in the folder 1. However, if I go back to my home directory, which is just, think of your directory that the desktop, the pictures, and all that are in Windows, that is your home directory. And you can see that we just have our normal group of files here for this specific example machine. But we can see that it's displayed here on the front of the terminal. However, it's easy to lose track of where we are in the file system exactly, which is why I want to introduce pwd. This stands for print working directory. I often remember this by present working directory, however, print is the correct one. Whichever one works for you to remember it, this is something that you'll pick up on very quickly with practice. Using the example machine from before, we are currently in the documents folder, but where exactly is this on the Linux machine's file system? We can find this out using the pw command like within the screenshot below. And we can see that we've done that down here. Let's go ahead and use pwd, and we can see where we are on our example machine over on the right. And we can see that we're in TryHackMe, that user's home directory. Let's break this down. We already know we're in the documents thanks to our terminal, but at this point in time, we have no idea where documents is stored at so that we can easily get back to it in the future. So we can see we're in the documents folder up here. I've used the pwd command to find the full file path of this documents folder, which we did right here, and we're returned the full path. We're helpfully told by Linux that this documents folder is stored at home Ubuntu documents on the machine. Great to know. Now in the future, if we find ourselves in a different location, we can use cd home documents Ubuntu documents to change our working directory to this documents directory. Let's dive into the questions. On the Linux machine you deploy, how many folders are there? And we can see that there are 4 folders. There we go. Which directory contains the file? So we've gone ahead and already looked in folder 1 and folder 2. Let's take a look in folder 3. And of course there's nothing. Of course it's the last one. Let's do ls folder 4. And we have note.txt. So that's going to be folder 4. Wouldn't it be funny if there were no files in any of the folders? That'd be great. What are the contents of this file? Let's go ahead and cat folder 4 note.txt. And it looks like it has hello world. There we go. Use cd to navigate to this file and find out the current working directory. What is the path? Let's go ahead and cd folder 4 and then use pwd to find our current working path. And we can see that it is home TryHackMe folder 4. There we go. Let's move into task 6, searching for files. Although it doesn't seem like it so far, one of the most redeeming features of Linux is truly how efficient you can be with it. With that said, you can only be as efficient as you are familiar with it, of course. As you interact with operating systems such as Ubuntu over time, essential commands like those we've already covered will start to become muscle memory. One fantastic way to show just how efficient you can be with systems like this is using a set of commands to quickly search for files across the entire system that our user has access to. No need to consistently use cd and ls to find out where things are. Instead, we can use commands such as find to automate things like this for us. This is where Linux starts to become a bit more intimidating to approach, but we'll break this down and ease you into it. That being said, one quick meta note, find here works a lot better than Windows search. This is actually worth learning, and there's an entire dedicated room to this, and you can see a note down here for that. I do highly recommend doing this room, especially after you've completed the Learn Linux series. It is one of the most insightful rooms on TryHackMe, especially for learning a critical command, so I highly recommend it. Using find. The find command is fantastic in the sense that it can be used both very simply or rather complex, depending on what exactly you want to do with it. In fact, so much so, we have an entire dedicated room, as I mentioned before. However, let's stick to the fundamentals first. Take the screenshot below. We can see a list of directories available to us, and we can see that over here. We have our directories listed out here as well. Now, of course, directories can contain even more directories within themselves, so you can have recursion there, and you can very quickly lose things, especially if you have a lot of layers of files. It becomes a headache when we're having to look through every single one just to try and look for specific files. We can use find to do just this for us. Let's start simple and assume we already know the name of the file we're looking for, but we can't remember where it is exactly. In this case, we're looking for passwords.txt. If we remember the file name, we can use simply find -name, so this is saying that this is the search criteria that we're using, and then passwords.txt. With the command, we'll look through every folder in our current directory for that specific file like so, and you can see it has done exactly that. Find has managed to find the file, and it turns out it's located in folder 1, with the file being passwords.txt. Sweet. But let's say we don't know the name of the file or want to search for every file that has an extension such as .txt. Find lets us do that too. We can simply use what's known as a wildcard or an asterisk right here to search for anything that has .txt at the end. In our case, we want to find every .txt file that's in our current directory. We will construct a command such as find -name star.txt, where everything before this dot is considered to be up for grabs, so it's a wildcard. Doesn't matter what's there as long as it has the .txt extension. Where find has been able to find every .txt file and has given us a location of each one, and we can see that down below. And we can see a breakdown of that too. That wasn't so tough, huh? Using grep. Let's take a look at grep. This is one of the most important tools as well that you'll want to learn with moving forward in Linux. This is a tool that, especially as you're learning to do CTFs and other challenges, grep is going to become your best friend. Another great utility that is a great one to learn about is the use of grep. The grep command allows us to search the contents of files for specific values that we are looking for. Take, for example, the access log of a web server. In this case, the access.log of a web server has 244 entries. That's a lot of lines. That is a lot to look through, especially if you want to do this in a timely manner. Using a command like cat isn't going to cut it too well here. Let's say, for example, if we wanted to search this log file to see things that a certain user/IP address visited. Looking through 244 entries isn't all that efficient considering we want to find a specific value. We can use grep to search the entire contents of this file for any entries of the value that we are searching for. Going with the example of the web server's access log, we want to see everything that the IP address, and I'll let you read that one yourself, has visited. Note that this is fictional. However, this access log, this is actually indicative of a real log. So great example. And this is actually something that if you are doing forensics or anything like that, or maybe a challenge to look through log files, you'll probably come across this at some point. Grep has searched through this file and has shown us any entries of what we provided and that is contained within this log file for the IP. Use grep on access.log, and I need to go up a directory for that, to find the flag that has a prefix of thm. What is the flag? Let's use grep, and then we want to look for thm star, and then we want to look in access.log. And there we go. We can see that it's highlighted that for us as well. So we have our flag, thm, access. Perfect. And I still have And we want to look for THM star, and then we want to look in access.log. And there we go. We can see that it's highlighted that for us as well. So we have our flag, THM, access. Perfect. And I still haven't found what I'm looking for. Wonderful song reference. Let's move into task 7, in introduction to shell. Operators. All right. Right. Linux operators are a fantastic way to power up your knowledge of working with Linux. There are a few important operators that are worth noting. We'll cover the basics and break them down accordingly to bite-sized chunks. I'm going to go ahead and skip past the overview. I definitely recommend having this in your notes. However, let's talk about these operators more in detail. Operator ampersand, or the single ampersand. This operator allows us to execute commands in the Operator ampersand, or the single ampersand. This operator allows us to execute commands in the background. For this case, it's generally referred to as the background operator. For example, let's say we want to copy a large file. This will obviously take quite a long time and will leave us unable to recommend having this in your notes. However, let's talk about these operators more in detail. Operator ampersand, or the single ampersand. This operator allows us to execute commands in the background. For this case, it's generally referred to as the background operator. For example, let's say we want to copy a large file. This will obviously take quite a long time and will leave us unable to do anything else until the file successfully copies. The ampersand shell operator allows us to execute a command and have it run in the background, such as this file copy, allowing us to do other things. This is very common, especially if you're doing something that might take a while. Backgrounding it and just letting it run while you still have the use of your terminal can be incredibly helpful. The double ampersand operator. This shell operator is a bit misleading in the sense of how familiar it is to the partner single ampersand of the background operator. Unlike the background operator, we can use the AND operator to make a list of commands to run. For example, we can do command 1 and then command 2. This is very similar to Boolean logic, or when you start getting into actual programming logic. However, it's worth noting that command 2 will only run if command 1 was successful. Very helpful if you have long commands you want to string up in a row. If command 1 fails, you don't want to run command 2, or maybe it'll break something. Very, very helpful. Operator, this is the single greater than sign. This operator is what's known as an output redirector. What this essentially means is that we're going to take output from a command we run, so output that would go to standard out, such as when we did echo hello. This would be the output right here. And take that and send that output to somewhere else. We're going to take it and move it to a different channel of that actual output. Don't worry too much about output channels. However, that's something that, especially as you get more experience within InfoSec, it's something you'll definitely want to learn a little bit more about. A great example of this is redirecting the output of the echo command, as I just demonstrated, and that we learned in task 4. Of course, running something such as echo howdy will return howdy back to our terminal. That isn't really all that useful though. What we can do instead is redirect howdy to something such as a new file. Let's say we wanted to create a file named welcome with the message hey. we can run echo hey and then have the output redirector operator and then the file that we want to create. If this doesn't exist, the redirection operator will create this file. However, if it does exist, it will overwrite the contents. And you can see a note on that down below here, where we want the file created with the contents hey, like so. And we can see a demonstration of that. So we've echoed hey and welcome, we've checked that the file has been created with ls, we've catted the file, and we found that hey is in that file now. And there we go. Let's take a look at the double greater than operator, otherwise known as the appending operator. This operator is also an output redirector, like in the previous operator, the single output redirector, or the single greater than that we previously discussed. However, what makes this operator different is that rather than overwriting the contents within a file, for example, it instead just puts the output at the end, which is great if we don't want to keep overwriting ourselves and maybe we want to log our information. Following on with our previous example, where we have the file welcome that has the contents of hey, if we were to use echo to add hello to the file using the single greater than or the output redirector operator, the file will now only have hello and not hey. It would overwrite it in that case. The appending operator allows us to append the output to the bottom of the file rather than replacing the contents like so. So we've gone ahead and echoed that using the append operator to welcome, then we've catted the file, and we can see that it's just added it to the bottom. If we wanted to run a command in the background, what operator will we use? That'll be the background operator, that is the single ampersand. If we want to replace the contents of a file named passwords with the word password123, what will my command be? That would be echo password123, and then a single greater than, and then passwords. And there we go. Now if I wanted to add TryHackMe to this file passwords, but also keep the passwords123, what would my command be? That would be echo TryHackMe, and then double greater than for the append operator, and then passwords. And there we go. Now use a deployed Linux machine to put these into practice, and I definitely recommend playing around with this just so that you're used to it. That being said, let's move into task 8, conclusions and summaries. Nice work on getting to this stage. We've covered quite a bit for your first interactions with Linux. However, these are the most essential functions you're going to be using whenever you interact with a Linux machine. I hope this room hasn't been too daunting for you to power through with these things very quickly, as we're introducing a lot very quickly. However, practice is key in this specific case. To quickly recap, we've covered the following. Understanding why Linux is so commonplace today, interacting with your first ever Linux machine. We ran some of the most fundamental commands, we had an introduction to navigating around the file system, and how we can use commands like find and grep to make finding data even more efficient, and then finally we learned how to power up our commands by learning about some of the important shell operators. Take some time to play around in this room. When you feel a bit more comfortable, progress on to Linux Fundamentals Part 2. Go ahead and take a play around, and then you can click on this link once you've gone ahead and terminated this machine to move on to Part 2. That being said, let's take a quick look at Task 9, and I'm going to show you how to terminate your machine. So this is a link to the second room in the series. I definitely recommend moving on to it once you are comfortable with these commands that we've introduced. Maybe run them a couple times just to start getting a little bit of practice with them, and then you'll want to terminate this machine. If you scroll up, you'll find this red terminate button. We can press it right here, and we've closed that machine. If you ever have issues with launching a machine, and you might have one still up from a previous room, you probably just forgot to terminate, so keep that in mind. Let's go ahead and mark that as completed as we've terminated the machine, and then we can go ahead and mark this next one as completed and join the Linux Fundamentals Part 2 room by clicking that link. That's going to do it for this video. I will see you next time in Linux Fundamentals Part 2, but until then, happy hacking! Hey everyone, welcome back to another video here on TryHackMe. I'm John, and today we're going to take a look at the Linux Fundamentals Part 2 room. Continue your Learning Linux journey with Part 2. You will be learning how to log into a Linux machine using SSH, how to advance your commands, and some file system interaction. That being said, let's go and dive right into Task 1. Welcome to the second part of the reworked Linux Fundamentals series. We'll be applying our knowledge from the first installment of the series, so I highly recommend you completing that room before proceeding further. In Part 2, we'll be ditching the in-browser functionality and help you get started in what is a fundamental skill in being able to log in to and control the terminals of remote machines. Not only this, but the room will also have you unlocking the potential of your first few commands by introducing you to using flags and arguments, advancing your knowledge of the file system to perform some more useful commands such as copying and moving files, introducing you to the access mechanisms in place to keep files and folders secure, and how to identify the things that our current user has access to, and then finally running your first few scripts and executables. Let's proceed. Go ahead and mark this as completed. Close that, and then move into Task 2, accessing your Linux machine using SSH. The in-browser functionality was used in Linux Fundamentals Part 1 to get you directly connected to your first ever Linux machine without any hassle. In fact, the in-browser functionality uses the exact same protocol that we are going to be using today. The protocol is called Secure Shell, or SSH for short, and is the common means of connecting to and interacting with the command line of a remote Linux machine. We will be deploying two machines in this room, your Linux machine and the TryHackMe attack box. What is SSH and how does it work? Secure Shell, or SSH, simply is a protocol between devices in an encrypted form. Using cryptography, any input we send in a human-readable format is encrypted for traveling over a network, where it is then unencrypted once it reaches the remote machine, such as in the diagram below. And here we can see we have our computer, the internet, which we're using to connect over, and then the Linux server that is remote or not in the same room as us. You can learn about the various types of encryption on a TryHackMe room. And one thing to note, you can use this with machines on your own network. This is just a nice way that you can connect to things from one computer and have everything, maybe your workstation, and you want to connect into a server that you're running, or things like that. But for now, we only need to understand that SSH allows us to remotely execute commands on another device and remotely. Any data sent between the devices is encrypted when it is sent over a network such as the internet. Deploying your Linux machine. Press the green Start Machine button at the top right of this task, and then scroll to the top of the page to see the deployment info like so. Let's go ahead and do that now. We'll start the machine, and we can see that we are given a couple pieces of information along with some commands. So the first thing that we have up here is the title. That's not very important. Don't worry about that for now. We have the IP address, which is what we're going to use to target the machine. This gives us sort of the street address that it's at, so we can send it mail. And then we have the expiration time. By default, all machines on TryHackMe currently have a 2-hour lifespan, so when you start them up, in 2 hours from that time, they will automatically turn themselves off. In this case, we can see that we also have another couple buttons. We have add 1 hour, so if this expiration time falls below 1 hour, we can add another hour to extend it in case we're taking a long time with the current machine or we want to continue working on it. And then we also have terminate if we want to turn this off. Note, this IP address is hidden for the first 60 seconds, I believe, and that is done because the machine's starting. It might be ready to go, but we want to give services time to start up, hence why it is hidden in that case. Let's go ahead and scroll down. We've already gone over that information, and then we also want to deploy the TryHackMe attack box. Looking at the top of the page, press the Start Attack Box button to deploy the TryHackMe attack box that we will be interacting with. We can scroll back up. We see this blue button right here. Go and click on that, and our screen is going to be divided here in just a moment. Now, this is our Kali machine that is already on the TryHackMe network. Now, one thing to note, if you are a free user, this will not have access to the internet. It can just talk to these other machines that we have spun up. Additionally, it's worth noting that as a free user, you have a maximum of 1 hour of usage of this per day. So once you start it, it needs to stay. If you want to continue using it, don't turn it off, and you have a full hour of that time. If you are a subscriber, you do have unlimited usage of this machine, and it does have access to the internet. Let's go ahead and continue down while we let these machines boot. Alright, using SSH to log into your Linux machine. The syntax to use SSH is very simple. We only need to provide two things: the IP address of the remote machine, and then correct credentials to a valid account to log in with on the remote machine. For this room, we will be logging in as TryHackMe, whose password is TryHackMe, not a strong password by the way, without the quotation marks. Let's use the IP address of the machine displayed in the card at the top of the room as the IP address, and this user to construct a command to log into the remote machine using SSH. The command to do so is SSH, and then the username of the account, and then @ IP address of the machine. And here we can see a breakdown of that command right here. Now, one thing to note, we do need to open up a terminal on the attack box once it starts in order to be able to type this command. That being said, we can see a screenshot of what that would look like down here, and we can give it just a moment for the machine to start. I'm going to go ahead and pause the recording now, and when we're back, we'll go ahead and log in. Alright, and we're back. The machine just finished booting. Now we have a little warning as well as some instructions. I'm going to click past this for now, and you can do the same. You just click into the terminal and then press enter to close that. Now we want to go ahead and open up our own terminal, and we can do that by double-clicking the terminal application there. And now we can log in. Let's go ahead and scroll back up to get the target IP address of the machine that we're going to connect to, and we will go ahead and connect to it using the command SSH TryHackMe at 10.10.137.96. And then we'll type in yes, and then our password for that user is TryHackMe, all lowercase. And there we go. I managed to type it in correctly. I went ahead and include this. Screen with Control and L, so I held down the Control key and then hit L. That just cleans up what loads right away, and then we can go ahead and move into the next tab. L, so I held uppercase. And there we go, I managed to type it in correctly. I went ahead and cleared the screen with Control and L, so I held down the Control key and then hit L. That just cleans up what loads right away, and then we can go ahead and move into the next task. We'll go ahead and mark this as completed and move into task. Task 3, Introduction to Flags and Switches. A majority of commands allow for arguments to be provided. These arguments are identified by a hyphen and a certain keyword known as flags or switches. We'll later discuss how we can identify what commands allow for arguments to be provided and understanding what these do exactly. When using a command, unless otherwise specified, it will perform its default behavior. For example, ls lists the contents of the working directory, however, hidden files are not shown. We can use flags and switches to extend the behavior of commands. Using our ls example, ls informs us that there is only one folder named folder1 as highlighted in the screenshot below. Note that the contents in the screenshot below are only examples and are not those of the instance you deploy in the root. So this is just an example, it won't be the case over here. However, after using the -a or -a argument, short for --all, we now suddenly have an output with a few more files and folders such as .hidden folder, and then we can see a couple other ones here. Files and folders with a period at the beginning are hidden files. A lot of times this is just system things or more configuration files that you don't necessarily need to see otherwise, and that's why these are hidden by default. Commands that accept these will also have a --help option. Sometimes this is -h, however not every command has a -h that specifies help. However, most commands that we can use have this --help option. This option will list the possible options that the command accepts, provide a brief description and an example of how to use it. This option is, in fact, a formatted output of what is called the man page, short for manual, which contains documentation for Linux commands and applications. The manual page pages are a great source of information for both system commands and applications available on both a Linux machine, which is accessible on the machine itself, and online. So here we can see that we have the online version of the man page. You can click into that and explore around. It can be very helpful for searching if you're not that comfortable with the command line yet. And this will also come up in Google results along with Stack Overflow. Both of those are a pretty good resource. To access this documentation, we can use the man command and then provide the command we want to read the documentation for. Using our ls example, we would use man space ls to be the manual pages for ls like so. And we can see an example up here. Explore the manual page of the ls command. Let's go ahead and do man ls, and there we go. Mark that as complete. And then what directional key will be used to navigate down the manual page? That is going to be the down arrow. Fairly self-explanatory. And then what flag will be used to display the output in a human-readable format? Now, we can scroll down, and eventually, we will find a -h command, or -h flag, rather, that allows us to specify that we want our output from ls to be in a human-readable format. And there we go. Let's move into task 4, file system interaction continued. Now we can go ahead and close the man page by pressing Q, and we can see that's down here as well. There we go. we covered some of the most fundamental commands when interacting with the file system on the Linux machine. For example, we covered how to list and find the contents of folders using ls and find, and navigating the file system using cd. In this task, we're going to learn some more commands for interacting with the file system to allow us to create files and folders, move files and folders, and delete files and folders. And you can see that you have the list here. I recommend adding that to your notes, and then we have a pro tip at the bottom. Similarly to using cat, we can provide full file paths, i.e. directory 1, directory 2, note for all these commands. So you can provide full paths for these as well as relative paths, which don't worry about that too much right now. This is just the full proper path to it on the system if you want to specify that. Creating files and folders with touch and make dir. Creating files and folders on Linux is a simple process. First, we'll cover creating a file. The touch command takes exactly one argument, the name we want to give the file we create. For example, we can create the file note by using touch and then space note, again where note is the name of the file. It's worth noting that touch simply creates a blank file. You wouldn't need to use commands like echo or text editors, or you would need to rather use commands like echo or text editors such as nano to add content to the blank file. And here we can see that down here after that has been created with touch. This is a similar process for making a folder, which just involves using the make dir command or mkdir command and providing the name that we want to assign that directory. For example, creating the directory my directory, we can do that with make dir and then the name of the directory right here, my directory, and we can see that's done in the example below. Removing files and folders with rm. Rm, short for remove, is extraordinary out of the commands that we've covered so far. You can simply remove files by using rm, however, you need to provide the $R switch alongside the name of the directory you wish to remove, in case you want to remove directory. So this is a recursive option, I believe, which removes the directory and all of its contents, as otherwise rm will say, hold on, I can't do this. So here we can see that we've removed note in this example, and that file is no longer here. However, to remove a directory, you can see it doesn't work without providing $R, but if we provide $R as a switch, it will remove it. Copying and moving files and folders with CP and MV. Copying and moving files is an important functionality on a Linux machine. Starting with CP, short for copy, this command takes two arguments, the name of the existing file and the name we wish to assign to the new file when copying. CP copies the entire contents of the existing file into the new file. In the screenshot below, we are copying note to note 2, and we can see that right here. Moving a file takes two arguments, just like the CP command. However, rather than copying and or creating a new file, MV, short for move, will merge or modify the second file that we provided as an argument. Not only can you use MV to move a file to a new folder, but you can also use MV to rename a file or folder, and you can just move it to the same location that it's already in if you want to just rename it. For example, in the screenshot below, we are renaming the file note2 to be named note3, and we can see that right here. Note3 will now have the contents of note2 because it was that file at one point. Determining file type. What is often misleading and often catches people out is making presumptions from files as to what their purpose or contents may be. This is something that's very common in CTFs, and this next command, especially for CTFs and in a situation where you don't have a file extension, is going to be very handy in those cases. Files usually have what's known as an extension to make this easier. For example, text files usually have an extension of .txt, but this is not necessary. Windows will require this for most files, and that's how it knows what program to open it with by default, and I believe OS X has a similar functionality with it. However, Linux doesn't really care. We don't have to have file extensions. It's recommended, as it is best practice, however, it's not necessary. So far, the files we have used in our examples haven't had an extension. Without knowing the context of why the file is there, we don't really know its purpose. Enter the file command. This command takes one argument. For example, we'll use file to confirm whether or not the note file in our examples is indeed a text file, like so. And you can see that we've done that with file, and then the file that we want to examine, and sure enough, it is an ASCII text file. How would you create the file named new note? We can do that with the command touch, and then the name of the file we want to create. On the deployable machine, what is the file type of unknown1 in TryHackMe's home directory? So we can do ls, and we have unknown1. We'll do file, unknown, and I can type part of that and hit tab to have it autocomplete. And there we go. We can see that it is an ASCII text file. There we go. How will we move the file, my file, into the directory my folder? We can do that with the mv command, and then my file, and then my folder. And there we go. What are the contents of this file? So let's see. We want to cat my file, there we go. And we can see that we have our flag thm file system. And there we go. Continue to apply your knowledge and practice the commands from this task. I do recommend playing around just a little bit so that you can become a little bit more familiar with these commands. Once you're ready, go ahead and move on to Task 5, Permissions 101. As you would have already found out by now, certain users cannot access certain files or folders. We've previously explored some commands that can be used to determine what access we have and where it leads. In our previous task, we learned how to extend the use of commands through flags and switches. Take, for example, the ls command, which lists the contents of the current directory. When using the -l or -l switch, we can see 10 columns, such as in the screenshot below. However, we're only interested in the first 3 columns. And you can see that right here, where we have the properties, and D right here, it's a little bit covered up by the outline, that specifies where there's a directory, and a dash in that first bit here specifies where there's a file. Then we have the file owner, and then we have the group that's an owner. One thing to note, on Linux, whenever you create a new user, there is a group that's created that's named the same as that user, hence why we have a user CMNATIC, and then we have a group CMNATIC. Although intimidating, these 3 columns are very important in determining certain characteristics of a file or folder and whether or not we have access to it. A file or folder can have a couple of characteristics that determine both what it is that, and who can do with it as. So in other words, it determines the owner and what we can actually do with it, if we can read, write, or execute the file. We can see that broken out down here below. The diagram below is a great representation of how these permissions can be translated, and we can see that we have these 4 different areas that we're looking at. And again, that's mirrored up here. So breaking this down, again, I mentioned this previously, that this first bit here specifies if it is a directory or just a regular file. Since we have a dash here, we know we're working with a file. Next, we have RWX. This is short for read, write, and execute. This first group here is the permissions that are available for the file's owner. Next, we have those in the same group as the file owner, and last but not least, everyone else on the system. And we can see that in this case, since RWX is available or printed at each one in every single space here, everyone can read, write, and execute this file in question. However, in this case, if we scroll up just a little bit more, we can see that there are examples where there are dashes instead of those letters. Where there is a dash, that permission is not available for those in that user group. So if we take a look at this example right here, we have that the user who owns this can read and write to it but not execute it, and everyone else can only read it. There's no write or execute set to be available. Let's use the cmnatic.pem file in our initial screenshot at the top of this task. And you can walk through this as well. So here we can see that we have the cmnatic.pem, where the owner can read and write to this file, but no one else can do anything, and the owner cannot execute that. This file, but no one else can do anything, and the owner cannot execute that. Briefly, the differences between users and groups. We briefly explored this in Linux Fundamentals Part 1, namely the differences between a regular user and a system user. The great thing about Linux is that file permissions, or permissions rather, can be very, very granular, that whilst a user technically owns a file if the permissions have been sent, then a group of users can also have either the same or a different set of permissions to the exact same file without affecting the file owner itself. Let's put this into a real-world context. The system user that runs a web server must have permissions to read and write files for an effective web application. However, companies such as web hosting companies will have to want to allow their customers to upload their files for their website without being the web server system user, compromising the security of every other user. So essentially, when you are interacting with a web system, or a website rather, such as TryHackMe, and you can upload something like a profile picture, you are running that actual process is running as a low privilege user that can't just overwrite files on the website. That wouldn't be very secure, because then we can upload whatever website we want on anyone's website. And that does happen. That is a common security issue. Okay, uncommon security issue, but it does happen. Switching between users. Switching between users on a Linux install is easy works thanks to the su command, short for substitute user. I like to remember this as switch user. It's not technically correct. Substitute user is the way that this is abbreviated from. Unless you are the root user or using root permissions through sudo, then you are required to know 2 things to facilitate this transition of user accounts. The user we wish to switch to, and then that user's password. You need to know that user's password in order to change to bnum, unless you are just super user. The su command takes a couple of switches that may be of relevance to you. For example, executing a command once you log in, or specifying a specific shell to use. You might have a specific shell you really want to use, such as bash or zsh. That's up to you, and that's outside of the scope of this actual room. Don't worry too much about this, just something to have as a general piece of knowledge. I encourage you to read the man page for SU to find out more. However, I will cover the -L or -- login switch. Simply by providing the -L switch to SU, we start a shell that is much more similar to the actual user logging into the system. So it simulates an actual login. The thing with this is we have that user's environment variables actually populate, which can be very useful, especially if we are in a programming environment where we need to have access to, say for example, we're assuming the web user that runs the website. We want to be able to access that user's environment variables, and we want them actually loaded into our current session. So it makes a big difference. If you have a development background, that will make a little bit more sense. For now, don't worry too much about it. Just if something's not working, you probably need to use this -L switch. For example, when using SU to switch to user 2, our new session drops us into our previous user's home directory. So we can see that using the login here, it is moving us to that home directory because we're actually simulating that login and we're switching what directory we're in. We're now, after using the -L, our new session has dropped us into the home directory of user automatically. And you can see if we don't use it, we just stay in our old home directory, where we don't have permissions for anything. Not very convenient. On the deployable machine, who's the owner of important? So we can go ahead and do ls-l, and we can see that important is owned by user 2. There we go. What would the command be to switch to user 2? We saw that before in our examples with su and then user 2. Now switch to this user 2 using the password user 2. We can use su, and then I'm going to use the -l to switch to that user's home directory. Actually, the password we saw that before in our examples with su and then user 2. Now switch to this user 2 using the password user 2. We can use su, and then I'm going to use the -l to switch to that user's home directory. Actually, we don't want that in this case. Su, user 2, and then user 2. And then we want to be able to read important. Let's go ahead and cat important. And there we go. Now, one thing to note, we could read this beforehand because the root permissions are enabled. However, we're reading this as the actual user now. And there we go. We have our flag, thm, su underscore user 2. And there we go. Let's move into task 6, common directories. First, we have /etc, or etc. This root directory is one of the most important root directories on your system. The etc folder, short for etc, and etc is the common way to pronounce this. It's pretty fast, and it's just commonplace within IT to call it that way or pronounce it that way, is a commonplace location to store system files that are used by your operating system. For example, the sudoers file, which allows that specifies who can run things with root permissions. Don't worry about this too much. It's outside of the scope of this room. Just know that it exists and something you'll eventually want to be familiar with. For example, the sudoers file highlighted in the screenshot below, which we can see right here, contains a list of the users and groups that have permission to run sudo or a set of commands as the root user. Also highlighted below are the passwd and shadow files. So we can see those right here. Those two files are special for Linux as they show how your system stores the passwords for each user in encrypted formatting called SHA-512. Don't worry too much about this. These are very powerful files. If you are in a system you don't own and you have root permissions, or if you can somehow access especially the shadow file right there, you can do very bad things. Don't worry about it too much right now. Just know that these files should be protected. You can read this passwd as any user, but you should not be able to read shadow. /var. The /var directory, with var being short for variable data, is one of the main root folders found on a Linux install. This folder stores data that is frequently accessed or written by services or applications running on the system. For example, log files from running services and applications are written here. So for example, specifically in the var log file, or in that directory rather, or other data that is not necessarily associated with a specific user, for example, databases and the like. Then we have /root. Unlike the /home directory, the root folder is actually the home for the root system user. This is just their home directory. And again, I preface this a little bit in Linux Fundamentals Part 1. This is just where your documents and everything that your user specifically owns will live. Pictures, your desktop, things like that. There isn't anything more to this folder other than just understanding that this is the home directory for the root user. But it is worth a mention, as the logical presumption is that this user would have their data in the directory, in a directory such as home/root, which is not the case. Root does have its own directory, and this is consistent off of, I believe, every single Linux distribution. There may be some bizarre Linux distribution that doesn't have this as a default rule, however, I've never come across it. /temp, or TMP. This is a unique root directory found on a Linux install, short for temporary. The temp directory is volatile and is used to store data that is only needed to be accessed once or twice. Now, one thing to note, don't put anything here you care about, especially don't take notes into this directory. It's something that as soon as the computer is restarted, which is referenced right here, this is cleaned out and everything in there is just wiped. I've made the mistake of storing things in this folder that I cared about. Don't make the same mistake. Don't store anything in there that you don't need very temporarily. What's useful for us in pen testing is that any user can write to this folder by default. Meaning, once we have access to a machine, it serves as a great place to store things like our enumeration scripts. You can store your shell here. Sometimes this won't be the case, but again, that's outside of the scope of the room. Generally speaking, /temp is going to be your friend just to check things into, as you can, by default, write to it. README, we've gone ahead and completed that. What is the directory path that we would expect logs to be stored in? That is var log. What root directory is similar to how RAM on a computer works? This is cleared on restart, and then that's the /temp directory. Name the home directory of the root user, and that is going to be /root, and then now apply your learning and navigate through these directories on the deployed Linux machine. I'm not going to do that in this case. I will let you practice this on your own. Once you're comfortable with this, move on to task 7, conclusions and summaries. And we'll do that right now. Nice work. This room was quite theory heavy and covered quite a range of the fundamentals in getting Hey everyone, welcome back to Utilities, final room in the Linux Fundamental series, and with that being said, let's go. Throughout the series so far, we have only stored text in files using a combination of the echo command and the pipe operators, so a single greater than, which is the redirection operator, and then the append operator, double greater than. This isn't an efficient way to handle data when you're working with files with multiple lines in the sorts. Introducing terminal text editors. There are a few options that you can use, all with a variety of friendliness and utility. This task is going to introduce you to Nano, but also show you an alternative named Vim, which TryHackMe is a room dedicated to. This is where checking out that room is very educational. Nano. It's easy to get started with Nano. To create or edit a file using Nano, we simply use the command nano and then the file name, replacing file name with the name of the file you wish to edit. And if that file does not exist and you have permissions to write that to that directory, you can use nano and then the file that you want to create for the file name, and then as long as you save when you exit, that file will be created. Otherwise, it will just either overwrite or start modifying whatever file you select, as long as you have permissions to write to it. Once we press enter to execute the command, Nano will launch, where we can just begin to start entering or modifying our text. So here we can see that after running that, we are greeted with the Nano text editor. This is a little bit small on my screen, however, going through and playing with this, you'll become very used to using Nano very quickly. It's very intuitive, and it's the text editor that I use pretty regularly on the command line. That being said, while we're going to go over Nano, it's worth having at least a minimum comfort level with a couple of the other text editors, just because Nano won't always be installed, and the other editors are not too tricky to learn either. That being said, let's go ahead and move on. You can navigate each line using the up and down arrow keys, or start a new line using the enter key on your keyboard. So very similar to less, and when we're reviewing the man pages, very similar to that, where we can navigate with the arrow keys. And here you can see we have a bunch of shortcuts here at the bottom. Nano has a few great features that are easy to remember and covers the most general things you would want out of a text editor, including searching for text, which you can see right here with the Control W, copying and pasting, and you should be able to see, I'm not seeing it, oh, there we go, right there. Jumping to a line number and then finding out what line number you're on. Very basic things, and they're very nice, especially if you need to edit a program, edit a script, or you're just taking notes in Nano. You can use these features of Nano by pressing the Control key, which is represented as a caret or an up arrow on Linux, and you can see that right here, and a corresponding letter. So for example, if we wanted to exit, we would want to press Control and then X to exit Nano. Now, one thing to note, if you've modified a file, it will prompt you to press Y or N to confirm if you want to keep those changes or discard them, and you can see the exit command over here in the corner in case you ever forget it. Let's talk briefly about Vim. Vim is a much more advanced text editor. Whilst you're not expected to know all advanced features, it's helpful to mention it for powering up your Linux skills. And here you can see this is the basic Vim text editor. Some of Vim's benefits, albeit taking a much longer time to become familiar with, include customizability. You can heavily modify the keyboard shortcuts to be of your choosing. I believe you might be able to do this in Nano as well. However, Vim, it's just a lot easier, and generally speaking, if you need advanced features, you're probably going to be moving on to using Vim anyways. Syntax highlighting. This is useful if you are writing or maintaining code, making it a popular choice for software developers. Very common to be using Vim, especially if you are in a development environment and you are just remoted into whatever machine is running your test web server. If you want to try a simple change in your test environment, changing it to Vim is probably your best option. Vim works on all terminals where Nano may not be installed. Nano's not always installed. Vim will typically always be installed. It's very rare to not have Vim available. There are lots of resources such as cheat sheets, and I recommend bookmarking this, tutorials, and sorts available for you to use. And again, TryHackMe is a room just on Vim. I highly recommend going through this. We mentioned previously in part 2 that there is a find command room. I recommend going through that and the Vim room. They are both very helpful, and especially the find command. It was very insightful when I went through it. Create a file using Nano. Let's go ahead and do that right now. So we'll do Nano, and then let's call it hello. So here we have the Nano text editor, very straightforward. We saw this earlier in the task. If I type something in here such as hello world, we can do Control X, and we can see that it wants just to confirm the changes that we've made to the file. And in this case, since we can write to it, we can write just press Y, and we save our file, and we confirm that the name of the file is going to be hello. Press enter, and there we go, we've exited. And if we run ls, we can see that we have hello available there. And if we check it as well using file, we can confirm that we created an ASCII text file. Pretty cool. Edit task 3 located in TryHackMe's home directory using Nano. What is the flag? Let's Let's do nano task 3, and we can see that our flag is THM text underscore editors. And there we go. Cool. Let's go ahead and close out of that. And note, because I didn't make any changes, Nano did not prompt me to confirm those changes. Let's move on to task 4, general/useful utilities. Downloading files. A pretty fundamental feature of computing is the ability to transfer files. For example, you may want to download a program, a script, or even a picture. Thankfully for us, there are multiple ways in which we can retrieve these files. We're going to cover the use of wget. This command allows us to download files from the web via HTTP, as if you were accessing the file in your browser. HTTP is just the basic web protocol for a website that's running without encryption. You've probably interacted with a website like this before. You don't need to know too much about the actual web protocols. Just know that this is one way that websites can respond. We see the other way, or the other major way I should say, is HTTPS. The S stands for encryption, so there is the SSL socket layer running there. Don't worry too much about that. It's outside of the scope of this room. Just know that that is there. This is in clear text, but it's useful if you just want to download things. We simply need to provide the address of the resource that we wish to download if we want to download something in this manner. For example, if I wanted to download a file named myfile.txt onto my machine, assuming I knew the web address it is at, it would look something like this. And you can see an example down below, where we have wget, and then we have the file that we're actually going to download. That downloads the file to our current working directory, so just wherever we're running this command from. Transferring files from your host using SCP via SSH. Secure copy, or SCP, is just that, a means of securely copying files. Unlike the regular CP command, this command allows you to transfer files between two computers using the SSH protocol to provide both authentication and encryption. Very, very helpful. And this may be overwhelming at first, but I promise you that the syntax on this is very intuitive once you've used it a couple times. Working on a model of source and destination, SCP allows you to copy files and directories both to and from your current system and remote systems. As long as you have SSH access, you can go through and copy files. Very cool and very straightforward. Provided that we know usernames and passwords for a user on your current system and a user on the remote system, we can go ahead and copy files from our machine to a remote machine. And here we can see that the command has already been laid out in this table. I'm going to go ahead and walk through it in the full command down below, and let's break this down now. First, we have the command SCP, which specifies that we're using secure copy. We are copying a file from our computer here, so the source is here. This would be flipped around if we wanted to grab this from a remote machine. However, we're grabbing something from our local machine named important.txt, and we're transferring it to a machine where we are logging into as Ubuntu, and then again, note this is the same syntax as SSH, with the IP address here, and then we have a colon with the actual location of where we're going to transfer that to. So, very straightforward. Think of this as SSH and CP if they were combined together. Again, if we wanted to transfer something from the remote system to our local system, it will be reversed, and we can see that down here below, where we have SCP, the command, which is just SSH, and then the actual location of the file, and then we're copying it to our current working directory and having it named as notes. Note, we can rename things as we copy. Again, this is very straightforward and very similar to what we saw with the CP command, the normal copy command. Serving files from your host with web. Ubuntu machines come prepackaged with Python 3. Python helpfully provides a lightweight and easy-to-use module called HTTP Server. This module turns your computer into a quick and easy web server that you can use to serve your own files, where they can be downloaded by another computer using commands such as wget and curl. Python 3's HTTP server will serve the files in the directory that you run the command from, but this can be changed by providing options that can be found in the man pages. Simply, all we need to do is run python 3-m for the module that we're going to run, and then http.server. Now note there's an extra space here. You don't need these two spaces, it's just one space. And even then, Python should just ignore that extra space. So running that will start the module, and note that this will occupy your terminal because it's a running process. This is an example where having this running in the background can be very helpful, especially if you want to work in one terminal and you're not working with something like tmux. Tmux and other multitasking solutions are again outside of the scope of this room, however, just know that they exist, and there are other ways that you can accomplish these tasks. In the screenshot below, we are serving from the directory called web server, which is a single file named file. So we are on this computer, the web server directory, in this user's home directory, and then we can see that there's this file, and then we run the Python 3 server, or the Python 3 web server rather, and note that it starts by default on port 8000. You can specify this by using the -p switch, and you can see more in the man page for this. There's a bunch of different options, and it's very, very cool. By and large, this is going to be one of your best friends as far as tools go, especially if you are going further into pen testing and need to transfer things to and from a remote machine. Now let's use wget to download the file using the computer's IP address and the name of the file. One flaw with this module is that you have no way of indexing, so you must know the exact name and location of the file that you wish to use. And the author talks a little bit about updog here. This is actually what I use as well. It is a very nice Python module outside of the scope of this room, but I definitely recommend looking into this as it is incredibly useful just for file transfers in general. That being said, here we have an example broken down. We are running ls to confirm that there's nothing in this current working directory of files, and then we are running wget. This is on our same host, so we're just downloading something from one part of our machine to another, but it's just an example. And we specify the full web URL, specifying that it is on port 3000, and that we want to, or 8000 rather, and that we want to pull the file named file. We can see that it is in the process of downloading it here, and this will actually move as you are running this command, so if it's pretty big, it will show a progress bar down here, and it's nice, it's very intuitive to use. Once we've completed that, we can see we've downloaded the file here. In the screenshot above, we can see that the wget has successfully downloaded the file named file to our machine. This request is logged by simple HTTP server, much as any web server would, which I have captured in the screenshot below. And here you can see that this is an example of the web server logs. We saw a little bit of this in the Linux Fundamentals Part 1 room, and you can see that that log is very much real. That was, I believe, an Apache 2 log. However, you can see an example of even how this, as a simple HTTP server, is able to actually do this. Ensure that you are connected to the deployed instance. We've gone ahead and done that. We've SSH'd in. If you have not, I recommend backtracking and making sure that you are SSH'd into it. Now use Python 3's HTTP server module to start a web server in the home directory of the TryHackMe user on the deployed instance. Let's go ahead and do that now. So I've cleared the screen. With Control and L, and we want to do Python 3-m http.server, and there we go. Again, like I said, this consumes your terminal, so running this in the background can be really helpful, or running it in another tab, which you can see up here. However, let me go ahead and not kill my process. There we go. And I'm going to go ahead and open up another tab, like so. We'll mark this as completed since we've gone ahead and pulled that file, or started the web server rather. Now we want to download a file hosted at this address. We can go ahead and do that now with wget http, and then 10.10.231.247, and then we need to do :8000 again because this is running on port 8000, and we're going to grab the .flag file, or .flag.txt file, and we're just downloading that to our current working directory. And there we go. It's pretty fast. We can see now if we do ls tac l to show, or ls tac a rather, and let me clear the screen. We can see that we have this .flag file now. If we Go ahead and cat.flag.txt. We can see that we have our flag for the web server, which is thm wget_web server. And there we go. Create and download files to further apply your learning, and this is something that you Control and C to interrupt that process and close it out. And again, I've cleared the screen. D associated with it, also known as C as process. We can use the friendly PS command, short for process, to provide a list of running processes as our user session, and some additional information such as its status code, the session that is running it, and how much time of the CPU it is using, as well as the name of the actual program or command being executed. And we'll dive into this in just a little bit to get more information on what's actually running on the system. Note how in the screenshot above, the second process, PS, has a PID of 204, and then the command below it has the 205. This is just incremented, and it's showing that each process is going to have a subsequent PID number incremented by 1. To see the processes run by other users, and those that don't run from a session, so for example, system processes, things that are started when your computer starts and they're just running on the computer without any user attached to them, we need to provide AUX to the PS command like so. And we can see by running that, we have a lot more information, as well as commands that aren't being run by our current user. So quite a bit of information, the user that's running over here, the PID, CPU and memory usage, a couple other bits of information which I won't worry too much about, the start time and date here, and then the command that's actually being run. Note that we can see a total of 5 processes. Note how we now have root and cmnatic here, so we can see that over there. Another very useful command is the top command. Top gives you real-time statistics about the processes running on your system instead of a one-time view. These statistics will refresh every 10 seconds, but will also refresh when you use the arrow keys to browse the various rows. Another great command to gain insight into your system is via the top command, or htop, which will give you a colored version of this. And you can see an example output of the top command there. Now, one thing to note, that is a process that you have to use Control-C to exit. It will take up your current terminal, and you just need to close it once you are done looking at what's actually running. Managing processes. You can send signals that terminate processes, and there are a variety of types of signals that correlate to exactly how cleanly the process is dealt with by the kernel. To kill a command, we can use the appropriately named kill command and the associated PID or process ID that we wish to kill. So for example, we can use to kill the process ID 1337, we'd use kill and then the process ID number. Below are some examples of signals that we can send to a process when it is killed. So we have sigterm, sigkill, and sigstop. This is kind of the varying levels of niceness that you can stop things with. So sigterm, we kill the process, but we do allow it to do some cleanup tasks. So we're telling it, hey, you need to stop, but you can clean up after yourself. Sigkill kills the process and it doesn't do any cleanup. And then sigstop just stops it. It doesn't allow it to do anything. It doesn't actually end the process. It's just pausing it, or suspending it in this specific case. How do processes start? Let's start by talking about namespaces. The operating system, or OS, uses namespaces to ultimately split up the resources available on the computer to processes. So those resources specifically we're looking at are CPU, RAM, and then the priority at which they run. Priority is how important they are for the system, and if there is contention for that CPU time, this is outside of the scope of this room, just as a heads up, if there's contention for the CPU and RAM usage, the higher priority process will get that, the priority there. Think of it as splitting up your computer into slices similar to a cake. Processes within that slice will have access to a certain amount of computing power, however, it will be a small portion of what is actually available to every process overall. Namespaces are great for security, as it is a way of isolating processes from each other. Only those that are in the same namespace will be able to see each other. So think of it as just kind of sections of like a cake. If you have a section of a cake and you hand it to someone else and they walk away with it, they don't know what the rest of the cake looks like. And that's kind of how a namespace works in this specific way. They might be able to guess, but ultimately they have no idea. We previously talked about how PID works, and this is where it comes into play. The process with an ID of 0 is a process that is started when the system boots. This process is the system's init on Ubuntu, such as systems, which is used to provide a way of managing a user's processes and sits between the operating system and the user. So what does this actually mean? This is the process that is the manager. It handles how the other processes actually run, and it's ultimately kind of the overlord of the process realm. For example, once a system boots and it initializes, systemd is one of the first processes that are started. Any program or piece of software that we want to start will start as what's known as a child process of systemd. This means that it is controlled by systemd, but will run as its own process, although sharing the resources from systemd to make it easier for us to identify and the likes. And here you can see that it has the PID of 1 in this example. And that's just taking a look at this with top. Getting processes/services to start on boot. Some applications can be started on the boot of the system that we own. For example, web servers, database servers, or file transfer servers. This software is often critical and is often told to start during the boot up of the system by administrators. Generally speaking, if you're running a web server and you want to have that web server constantly running on that machine, whenever you reboot it, you want it to start up automatically. And that's where this can be really useful. This is also very useful if you're hosting game servers and other things like that. In this example, we're going to be telling the Apache web server to be starting Apache manually, and then telling the system to launch Apache 2 on boot. Don't worry too much about what this is, again, outside of the scope of this room, just know that this is a general and very common web server that we will see in the wild. Enter the use of systemctl, or system control. This command allows us to interact with the systemd process/daemon, and continuing on with our example, systemctl is an easy-to-use command that takes the following formatting. So we have systemctl, the actual option that we want, so for example, these options down below, and then what service we're actually targeting. Very straightforward. Once you do this a couple times, this is very intuitive, and something that's very, very easy to guess at what the service name is. For example, to tell Apache to start up, we'll use the systemctl start as the actual option, and then we're targeting the Apache 2 service. Seems simple enough, right? Same with if we wanted to stop Apache 2, we just replace the option right here with stop instead of start like we provided. And here are the 4 options that we have. So minus status, there are a couple more options here. Status will tell you what the actual status of that process is, if it exited with an error or if it's running, so on and so forth. Then we have start, stop, enable, which enables it to actually run at startup, and then disable, which tells it, hey, I don't want you to run at startup. An introduction to backgrounding and foregrounding in Linux. Processes can run in 2 states, in the background and in the foreground. For example, commands that you run in your terminal, such as echo, or things of that sort, will run in the foreground of your terminal, as it is the only command provided that hasn't been told to run in the background. And again, I prefaced this a little bit earlier when we were talking about having things running in your terminal and kind of consuming that space. Running things in the background, especially if you're doing a file transfer that's going to take a while, it's easy just to background them and then forget about them until they're done. Echo is a great example, as the output of echo will return to you in the foreground, but it wouldn't in the background. So here we can see that we're running echo, and this is without it being backgrounded, and we run it again, so normal output there, running it again with it being backgrounded, and it gives us back our input, or the actual echo here later on, after it's started this background process with this process ID. Here we're running echo hi THM, where we would expect the output to return to us like it is at the start, but after adding the ampersand or the background operator to the command, we're instead just given the ID of the echo process rather than the actual output it is running in the background. This is great for commands such as copying files, because it means that we can run the command in the background and continue on with whatever further commands we wish to execute without having to wait for the file to finish copying first. We can do the exact same when executing things like scripts. Rather than relying on the background operator, we can use Control and then Z to force a process to background. This is an effective way of pausing the execution of the script or command, like in the example below. So we have this process that's running on loop, and it's just permanently running on loop until we cancel it, or just tell it to sig kill or something like that. We are going to go ahead and force it in the background with Control and Z, and it's just running in the background. It's no longer consuming our terminal, and we have our terminal teletype prompt back up. This script will keep on repeating. This will keep on looping until I stop or suspend the process. By using Control and Z, as indicated by the caret and then Z right there, we've gone ahead and background it, and our terminal is no longer filled up with these messages, until we foreground it, which we'll discuss right now. Foregrounding a process. Now that we have a process running in the background, for example, our script background.sh, which can be confirmed by using the ps-aux command, we can backpedal and bring this process back to the foreground to interact with, as this is just going to keep running in the background until it finishes or until we kill it. With our process backgrounded using either Control and Z or the ampersand background operator, we can use FG, that command, to bring this back to focus like below, where we can see the FG command is being used to bring the background process back into use on the terminal, where the output of the script is now returned to us. So we've run the foreground command, FG, and now our terminal is filled with garbage, but we brought it back to the foreground. README. We've gone ahead and done that, so we'll mark that as complete. If we were to launch a new process, or a process where the previous process ID was 300, what would the ID of this new process be? That's going to be 301. Again, that increments by 1 every time we run a new process. If we wanted to cleanly kill a process, what signal would we send it? That should be sigterm, and that gives the process time to clean up after it's off and things. Locate the process that is running on the deployed instance, what flag is given. So we're going to go ahead and run ps-aux, and then I'm going to use a couple other things that we haven't necessarily learned to make this easier for the sake of the video. I'm using the pipe operator, which takes the output from this ps-aux command and passes it straight into another command called less. Less is like catting things, but it gives us the ability to scroll through the output, and it's much easier for the sake of the video. So we can go ahead and scroll down, and at some point we'll be able to see a flag just kind of hanging out in here. And it might take a moment, but we should be able to find it. There we go. So here we can see, and it's a little bit squished because I have everything zoomed in on my screen, but we have THM and then processes for our flag. Again, that increments by 1 every time we run a new process. If we want after it's off, run ps-aux, and then I'm going to use a couple other things that we haven't necessarily learned. To make this the video. There we go. So here we can see, and it's a little bit squished because I have everything zoomed in on my screen, but we have THM and then processes for our flag. Processes. There we go. What command will be used to stop the service, my service? And that would be the, let's see. We want system CTL stop my service. Took me a moment to think about that. What command will be used to start the same service on boot up of the system? That would be system CTL enable because we want it to run on boot, and then my service. And then what command will be used to bring a previously backgrounded process back to the foreground? That will be FG, short for foreground. Let's go ahead and move into task 6, maintain your system with automation. Users may want to schedule a certain action or task to take place after the system is booted. Take, for example, running commands, backing up files, or launching your favorite programs on such as Spotify or Google Chrome. We're going to be talking about the cron process, but more specifically, how we can interact with it via the use of cron tabs. Cron tabs are one of the processes that are started during boot, and it's responsible for facilitating what are known as cron jobs. Think of that as just auto-starting things. Their tasks, for example, I believe Windows, it's called Task Scheduler. I haven't used it in a little bit, but that is the same way that you would do that on Windows, and I'm sure that OS X has a similar way to do this as well. A cron tab is simply a special file with formatting like so, and we'll walk through this in a moment, that is recognized by cron, or by the cron process to execute each line step by step. Cron tabs require 6 specific values, and we can see that these values, these first 5, are so we can specify when we want this to run, and then the actual command we want to run. Pretty straightforward. I won't walk through this. I recommend adding those to your notes though. Let's use the example of backing up files. You may wish to back up CMNATIX documents every 12 hours, and we would use the following command formatting to do exactly that. So here we see that we have our full command written out. An interesting feature of cron tabs is that we also support the wildcard asterisk, and this can be found on the 8 key to actually specify that we want this to run at every single interval in that specific field. If we do not wish to provide a value for that specific field, i.e. we don't care what month, day, or year it is executed, only that it is executed every 12 hours, we simply place an asterisk. And here we can see that in this first field that we're specifying that this is going to happen at the start of the hour, every 12 hours, and every day of the month, on every month of the year, and every day of the week. So, and then we have actually our command here at the bottom, or at the end of that. This can be a little bit confusing to begin with, and don't worry too much about this. This is something that you just need to have a general knowledge of. However, there are some great resources online, such as the cron tab generator. I recommend bookmarking that, and that allows you to use a friendly application, or it's a friendly application rather, to generate formatting for you, as well as the site Cron Guru. So if you know what you want to do, but maybe you're not the most comfortable with this formatting, you can use cron tab generator to get it all whipped up for you. Pretty straightforward. Cron tabs can be edited using cron tab-E, specifying edit, where you can select an editor, such as Nano, and it will prompt you for this on your first time using this to edit your cron tab. And here you can see an example of the cron tab generator there. And we can see editing it with Nano down below. Ensure you are connected to the deployed instance and look at the running cron tabs. So let's go ahead and use cron tab-E, and we can see all the cron tabs on the system. And if I scroll down, we can see that there is one process. How frequently does this cron tab run? This is a special instance of how we can run this with at reboot, specifying that every time the system reboots, we want to run this process. And there we go. We can go ahead and use Control X to now exit Nano and exit editing that cron tab. Let's move into task 7, maintain. in your system with package management. Introducing packages in software repos. When developers wish to submit software to the community, they will submit it into an apt repository. If approved, their programs and tools will be released into the wild. Two of the most redeeming features of Linux shine a light here: user accessibility and the merit of open source tools. When using the ls command on Ubuntu 20.04, don't worry too much about this release number. It's just the same as like Windows 7 or Windows 10, and specific subversions of that rather. Linux machine, these files will serve as the gateway/registry. Don't worry too much about this. This is just so that you have a general idea of how you can add different sources in. If you ever install something such as Sublime Text, the Sublime Text website will give you the command to do this, and just having a general idea of where this is actually taking place is the important part. So here we can see that we have our sources.list file. This is the directory that all this information is stored in, and then we have the sources.list file here. This shows all of the sources that we're pulling things from whenever we want to go through and update things. So for example, when using the apt command, which we'll go into in just a moment, this is what it's actually looking at. Whilst operating system vendors will maintain their own repositories, you can also add community repositories to your list. This allows you to extend the capabilities of your operating system. Additional repositories can be added using the add apt repository command or by listing another provider. For example, some vendors will have a repository that is closer to their geographical location, and that's fairly common to see. This is also something that if you install Docker, you will probably have to add in a new repository for this, as the default installation or the default one that's available in these repositories is usually out of date. Managing your repositories via adding and removing. Normally, we can use the apt command to install software onto our Ubuntu system. The apt command is a part of the package management software, also named apt. Apt contains a whole suite of tools that allows us to manage the packages and sources of our software, and to install or remove software at the same time. Let's walk through adding or removing a repository using add apt repository, or the add apt repository command we illustrated above. Whilst you can install software through the use of the package installer, such as dpkg or Debian package, the benefits of apt means that whenever we update our system, the repository that contains the pieces of software that we add also gets checked for updates. So think of this as just a more automated way of doing installing new things to our system. In this example, we are going to add the text editor Sublime Text, great example as I mentioned above, to our Ubuntu machine as a repository, as it is not part of the default Ubuntu repositories. I believe this might have changed. I think it might actually be in there now. However, this is still a great example. When adding software, the integrity of what we download is guaranteed by the use of what is called GPG, or New Privacy Guard keys. If you ever are communicating securely with email, finding a GPG key like this is very common, and this is something that if you are interested in privacy on the internet, I definitely recommend looking a little bit more into. It's a very fascinating topic. These keys are essentially a safety check for the developer saying, here's our software, and this is kind of a digital fingerprint that verifies, hey, this is coming from who we think it's coming from. If the keys do not match up with what your system trusts and what the developers used, then the software will not be downloaded. So, to start, we need to add the GPG key for the developers of Sublime Text 3. Note that the TryHackMe instances don't have access to the internet, so we're not actually expecting you to follow along here. This is just so you understand what this process looks like. And a lot of times, whenever you're installing something like this, you're going to be given the commands anyways, so don't worry too much. Just feel free to sit back and just follow along. Let's download the GPG key and use apt key to trust it. So here you can see we're using wget to download this GPG key, and then we are piping it, like I used before, to sudo add or apt-key add and then dash. Don't worry about the breakdown on that. We're downloading the key and just adding it to our trusted sources. Now that we've gone ahead and done that, what we can go ahead and do is add that repository to our apt sources list, and a good practice is to have a separate file for each different community / third-party repository that we add. Let's create a file named sublime-text.list in etc apt sources.list.d. and enter the repository information like so. So we're going to put a file in this folder, and here we can see that we've created that, and we're going to go ahead and edit it with a similar formatting to what we saw above. This is just the repository that we're adding. It is good practice to add a comment here saying, hey, I used this repository for this is why it's here, just to have a little bit of backup information there. It's pretty straightforward with Sublime Text, but when you start adding a lot of these in, which you might do, it just depends on your use case for Linux, it is good to have these all annotated, especially at the time of downloading it, because you know what you're using it for. After we've added this repository, we need to update apt to recognize this new entry, and we can do this with the apt update command. Once we've successfully left that complete, we can now use apt to install software from that repository, such as using the command apt install sublime-text. And then we can reverse that for uninstalling things if we want to remove a repository. And we can see just an example of that there, and this will automatically remove the repository, and then if we wanted to remove the software package, we can do that like so. And here's an example if we wanted to uninstall Sublime Text. Since TryHackMe instances do not have an internet connection, just make sure that you've understood what's going on here as a general process, that we are adding the key so that we know what to trust, and then we're adding where we're actually downloading things from, and then we have the ability to install new software. Let's mark that as completed and move on to task 8, maintaining your system with logs. We briefly touched upon log files and where they can be found in Linux Fundamentals Part 1. However, let's quickly recap. Located in the var log directory, these files and folders contain logging information for applications and services running on your system. The operating system, or OS, has become pretty good at automatically managing these logs in a process that is known as rotating. I have highlighted some logs from 3 services running on an Ubuntu machine. We have an Apache 2 web server log right over here, a Filtrband log service. If you ever do cyber defense clubs, Filtrband is going to be your best friend. This is a way that you can prevent brute force logins. Don't worry about this too much, but if you ever do cyber defense or things like that, this is a great thing to know about. And then UFW, or uncomplicated firewall, which as it sounds is just a firewall service. Also very useful if you're doing a cyber defense competition. These services and logs are a great way of monitoring the health of your system and protecting it. Not only that, but the logs for services such as a web server contain information about every single request, allowing developers or administrators to diagnose performance issues or investigate an intruder's activity. For example, the 2 types of log files below are of interest, where we have an access log and an error log. This is what people actually do and what errors are generated. And you can see that we have examples of that here in the Apache 2 directory. There are, of course, logs that store information about how the operating system is running itself and actions that are performed by users, such as authentication attempts. If you go into the defensive side of information security, this is something you will look into pretty heavily, especially using monitoring sources such as Splunk or any other SIM. There are a whole bunch of rooms on that. If that's something that interests you, I recommend going through the beginner pathway and then moving into a defensive pathway, which if it's not released at this time, it will be released fairly soon afterwards, so just keep that in mind. Look for the Apache 2 logs on the deployable Linux machine, so we can go ahead and cd to var log Apache 2, since we know where it's at from the example. You can also look in the var log folder and just find it that way. Mark that as completed, and then we need to find the IP address of the user that visited the site. Now, if we take a look at the ownership permissions of these files, we'll find that there are only 2 files that we can actually read. We have this error log, which gives us permissions right there, and then we have the access log. So if we're looking for someone that successfully visited the site, we're going to take a look at this access log.1. Let's go ahead and use less and then access.log.1, and we can see that we have our IP address right over here. And that is going to be 10.9.2.3. Two. .1.1.1. And then what file do they access? That is going to be catsanddogs.jpg. Catsanddogs.jpg. And there we go. We can press Q to close out of LAN. catsanddogs.jpg. And there we go. We can press Q to close out of less, and then I'll do Control-Alt to clear the screen. Let's move into our final task, conclusions and summaries. Welcome to the end of the Linux Fundamentals module. Your familiarity with Linux will improve as you get to interact with it over time. Practice makes perfect as you use it, and you'll probably start using it on a daily basis. Even if you're not using it now, as you practice, you'll get used to this very quickly. Linux has the potential to do very powerful things with relative ease, as you have hopefully discovered throughout this module. To recap, this room introduced you to the following topics: using terminal text editors such as Nano and Vim, general utilities such as downloading and serving contents using a Python web server, and I do recommend looking at UpDog. It is worth your time. It'll take like 5 to 10 minutes. A look at the processes, and then finally maintaining and automating your system by the use of cron tabs, package management, and reviewing logs. Continue your learning in some other TryHackMe rooms that are dedicated to Linux tools or utilities. And there's a couple things that we mentioned here. First, we have the find command. Excellent room. This is one of my favorite rooms on TryHackMe, just to give you a general idea and very comprehensive understanding of how to use this in your daily workload. Rooms on TryHackMe, just to give you a general idea and very comprehensive understanding of how to use this in your daily workload, and especially as someone working in information security or even just general IT. Then we have a room about bash scripting, and then another one about regular expressions. Terminate the machine deployed in this task from task 2. Let's go ahead and scroll up. We'll terminate that there, mark that as completed, and then continue your learning in other Linux dedicated rooms. We'll mark that as completed, and that's going to do it for this video. If you have any questions, as always, we have the TryHackMe Discord and TryHackMe subreddit linked in the video description below. But until next time, happy hacking!
Everybody, this is the Helpful Hacker, and today we're going to be going over TryHackMe's Windows
Windows OS exists in more than 8.
What's up, everybody? This is the Helpful Hacker, and today we're going to be going over TryHackMe's Windows Fundamentals 1 room. So we'll jump right into that with task number 1. So first, it's just going to have you start your machines. In order to use this room, you do have to be subscribed, so you can check out the link in the description. You get a $5 credit when you use that link to sign up for TryHackMe. So then I already started my attack box, which I have in a different tab right over here. And then I've already started this target machine right over here. Then I already started my attack box, which I have in a different tab right over here. And then I've already started this target machine. I always like to use the attack box because I'm lazy. You can set up OpenVPN and use your own computer, but whatever, I'm lazy. So task 1, what task 1 wants us to do is it wants us to remote desktop into the Windows machine. So you can read a little bit about that right here. And so to do that, we'll open up a terminal and we'll use a tool called xFreeRDP. And the syntax for this is going to be /u for username. And wait, what is the username? The username is administrator. I almost just typed in username. And then the password. Let's look at the password. It's familiarity with it, I guess. Yeah. So read through that. I mean, it's good to have some familiarity. You have the taskbar, and then you have some other little stuff over there. I think that's called the task, with task number 1. So first it's just gonna have you start your machines. In order to use this room, you do have to be subscribed, so you can check out the link in the description. You get a $5 credit when you use that link to sign up for TryHackMe. So then I already started my attack box, which I have in a different tab right over here, and then I've already started this target machine. I always like to use the attack box because I'm lazy. You can set up OpenVPN and use your own computer, but whatever, I'm lazy. So task 1, what task 1 wants us to do is it wants us to remote desktop into the Windows machine. So you can read a little bit about that right here. And so to do that, we'll open up a terminal and we'll use a tool called xFreeRDP. We'll open up a terminal and we'll use a tool called xFreeRDP. Whatever, I'm lazy. So task 1, what task 1 wants us to do is it wants us to remote desktop into the Windows machine. So you can read a little bit about that right here. And so to do that, we'll open up a terminal. and we'll use a tool called xFreeRDP. Password 206. And with that, we should be able to jump in. Here we go. xFreeRDP. Okay, so now we've remote desktop into the actual target machine. xFreeRDP. Okay, so now we've remote desktop into the actual. Target machine. So we can scroll down here, hit complete, and there's other things you can use besides xFreeRDP. That's just what I always use. Again, with most things, there's 1,000 tools, so just figure out which one you like and use it. Now this task 2, now that we're done with task 1, on to task 2, Windows editions. It's just going to walk you through kind of the history of Windows and some of the different editions of it. Yeah, so read through that. I mean, it's good to have some familiarity with it, I guess, because occasionally you might be working on older computers or older boxes, that kind of stuff. But yeah, so just read through it. I'm not going to go through it. It's pretty straightforward. Different versions, you know, new versions of anything. It's all the same. So then we'll move on to questions. And the question here at the bottom, this is a question you just have to Google. It's not in the actual thing. And the answer is BitLocker. So don't just copy me and write it down. Go double check, figure out how, because then in the future, if there's other Windows editions and you want to know what features they do or don't have, you can figure that out on your own. Okay, so that's task 2. We're done with that. Now it's on to task 3, the desktop GUI. So pretty much you have the desktop, you have the start menu, you have the search bar, and you have the task bar. And then you have some other little stuff over there. I think that's called the task view. What is that? Yeah, task view. I don't use that, so do with that what you will. And this is just giving you kind of a general thing because, again, new versions of Windows are going to look slightly different from this, but you'll always have some of the major things like a start button, a search bar, task bar, and a desktop, you know, so take a look at that, read through all these. They have display settings, so you can edit a bunch of stuff. You can personalize a lot of it, and then this is what the start menu looks like, or the search bar. So yeah, look at that, mess around. The biggest thing is just jump over here and start clicking on stuff, seeing how things work, right? Like what's the difference between the search bar versus start menu. You can right click on stuff, you can pin it to start, or I could take that, unpin it from start. What else can I do? Oh, I could take that. Well, let me pin to taskbar, there you go. So all sorts of cool stuff. So you can customize your Windows machine. Okay, and then you can search stuff by just typing it in, or in the, I think this is in the start menu. Yeah, in the start menu, you can, like, if you have a lot of apps, you can select a letter and it'll show you all the apps starting with that and whatnot. So yeah, just read through this. It's pretty straightforward. And then down to the questions, which selection will hide or disable the search box? So to figure that out, I would just right click here, search, hidden. My guess is that that's gonna do it. Yep, if you do that, the search bar box is hidden. So we'll go undo that. Oh, wait a minute, come on. Search, show search box. So to hide it, that would just be hidden. Submit that and you're good. Which selection will hide or disable the task view button? My guess is show task view button, which I'm gonna leave off because who uses that? Show task view button, that's correct. Besides clock and network, what other icons are visible in the notification area? So I don't know if I covered that, but this whole little chunk right here, this is the notification area. So there's network, there's the clock, and then what is this guy? So this actually took me a minute. It's the action center. I kept on trying to figure out what the crap was over here, and I thought this was just like notifications because it says no new notifications. But yeah, the answer to this question is the action center, which, whatever. Yeah. So go through that, answer those questions, familiarize yourself with the GUI or the graphical user interface. And with that, you're done with task 3. Now it's on to task 4, the file system. So in modern versions of Windows, they use NTFS, which stands for New Technology File System. And before that, they used FAT16 or FAT32 and HPFS. And you can see what those stand for right there, File Allocation Table, High Performance File System, but those are old. So there are still FAT partitions in use today for different things, like USB, microSD, and other stuff. But on a personal computer, laptop nowadays, if you have someone who has a Windows computer, it's going to be NTFS, New Technology File System. And there are some cool features of that were not included in previous filing systems, hence why it was probably created. So in case of a failure, the New Technology File System can automatically repair folders and files based on information stored in logs. And then it can also do all this good stuff that the other file systems couldn't. So read through that. Basically, it's better. So then let's see, what did they talk about here? So if we want to see the file type that we have, we can just go to the file system. This little symbol right here, this gets you to the GUI for the file system. Then you can go to this PC, and then go to local drive C, go to properties, and we can see right there, file system and TFS. So that's how you can find that if you want to find it on your computer, just to confirm. And it's good to know in case you're ever working with a computer that's not yours, you can figure out what file system they're using and what all that means. So with NTFS, you can set permissions, and you can do that with files and folders. And the permissions are full control, modify, read and execute, list folder contents, read and write. They're all pretty straightforward. You can read something, so you can look at it. You can write to something, which means you can write to the file or add to it. You can read and execute, which means you can read it and you can execute a file. And then here for meaning for folders, you can kind of read through that because it is slightly different. The meaning for files is pretty intuitive though. So list folder contents, that one only applies to folders. You can list its contents. Modify, that means you're allowed to edit it or delete it, right? You can modify it. And then full control, that's going to permit reading, writing, changing, and deleting of files and subfolders. So yeah, more often than not, you have full control of whatever it is you're doing. So, but yeah, with different files, and we'll get into this, there's different permissions. So you can view the permissions for a file, right click it, go to properties, go to security, and the groups are usernames. You'll see users and it'll look like this, and it'll give you permissions for whatever user you selected. So to do this, we'll go to the Windows folder, because the Windows folder, we'll talk about it more later, but it has different file permissions. So like, look, right here we can see, let's do system. So system has special permissions. Administrators also have special permissions. Who's this? Users. So users can read and execute list folder contents and read. So as you can see, as you click through different users, they will have different permissions, and you can see that right there, which is pretty cool. So, and you can learn more about special permissions. Just Google it. It's basically, yeah, I mean, I don't know how to describe it other than they're special permissions that don't exactly fall into the other categories. So another feature of NTFS is alternate data streams. So you don't need to know a ton about this right now, but just know that it exists. Every file has at least one data stream, like its main primary data stream, and that's kind of represented with this $sign data. But NTFS allows for more than one data stream. So basically, I'll just give you an example. Let's say I have a text file. I can open that text file, I can close that text file, I could send that text file to somebody else. So it functions just like a normal file. If I have any sort of file, there's nothing on here that tells me, even if I open the file, that there's an alternate data stream. Like the computer doesn't just tell me that at all. And so even if I go to let's go to properties on this, right? You look through it, you can try, but there's really nothing that's going to tell you there's an alternate data stream there. And so because of that, in the past, people have hidden malware, or you could hide a secret message in an alternate data stream. That's something, if you want to know more about it, just do it. Just literally hop on a Windows machine and Google how to, use an alternate data stream, and it'll all make a lot of sense. But basically, you can hide stuff in a file and the computer won't actually tell you that it's there. And that's what an alternate data stream allows us to do if we want to use it maliciously. Now, there are good reasons for it. It has to do with metadata and other stuff. So that's why NTF has it, but it can be used for bad stuff. Also, it's not like you can't find out if something has an alternate data stream. You just have to put in a bit of effort, and you usually do that through PowerShell, and then you can view whether or not there's an alternate data stream for files. But you're not just you have to get into PowerShell and actually use it, which, if you don't know what that is, I'll just open it for you. Right, so you have to get into this, and you have to start typing commands and everything in order to actually see an alternate data stream. But that's what it is. You should know that it exists. Other than that, don't worry about it too much. So the answer to this is new technology file. So what's the meaning of NTFS? New technology file system. It's the new file system that Windows likes to use. So with that, we are done with task number 4. Now it's on to task number 5, the Windows system / system 32 folder. So basically in Windows, there's a folder, and we already saw it. If we go back to our local drive, this Windows folder right here, there's a ton of stuff in there, right? And that is basically the folder that contains the whole Windows operating system. And this folder doesn't have to be in the local disk C, but 99% of the time, that's where it's going to be. And there are special environment variables for the Windows directory, for this Windows directory, and that special environment variable is %win_ir and then %. And so basically all you need to know about that is that's an environment variable that points to the Windows folder. And it says, hey, this is where the operating system is. And that's used for a lot of stuff like programming stuff and building things. So you don't really have to worry about it too much, but know that this %win_ir%, that's basically pointing you in the direction of this Windows folder that contains the whole Windows operating system. That's all you need to know for now. This can be used for several other useful things, but we're not going to talk about it. This room doesn't cover it. So then the next part it wants to talk about is inside the Windows folder, which has pretty much the whole Windows operating system, you have a folder called System32. And I couldn't tell you for the life of me why it's named System32. But what's important about the System32 folder is it holds the important files, the most important files that are critical for the operating system. So if you mess with the System32 folder, there's a chance your whole computer might just like not work at all, because everything in there is very critical for the OS to operate correctly. So you can read more about it right here, follow that link, and then we'll move on down to the questions now that we've reviewed the Windows folder containing the operating system and the System32 folder containing critical parts of that operating system and the %win_ir% environment variable that points to this Windows folder. So that also answers this question: what is the system variable for the Windows folder? That is %win_ir%. There it is. And with that, we are done with task number 5. Now it's on to task number 6, user accounts, profiles, and permissions. So generally there's two types, administrator and standard user. Kind of gives you the difference here. The administrators can make changes to the system, like add users, delete users, change groups, change settings, a bunch of other stuff. Standard users can only make changes to folders and files attributed to the user, and they can't do system level stuff, like install programs. So that would be, an administrator type thing. So currently in this machine, we are logged in as administrator, which is cool. And there you go, it says it right there, administrator. So we're important. So we're currently logged in, and we can check out other users. You can click the start menu, other users, and see what happens there. So I guess we'll just take a look just for fun. If we go to other users and TryHackMe, so there's another user, and it's the TryHackMe, and it's a local account. Cool. Okay, so that's what that is. You can look at other users. Because we are an administrator, we have the option to add someone else to this PC. So yeah, let me see. It wants us to kind of go through that, so I guess I'll show you that. But basically, we'll go back to where we were, other users, add someone else to this PC, and then it takes us to this thing, which I assume they'll get into next. Wait a minute. Oh no, they want us to mess with this, so we can change the account type. Basically, they're just trying to show you there's a other user on here, but because we're the administrator, we can mess around. We can do all sorts of cool stuff. We can make them an administrator, or do whatever. So perks of being an administrator, you're basically in charge of the computer, and so most of the time you are actually the administrator of your computer. But yeah, I think they talk about that more later. So each user profile will have some of the same folders, so that's just like the basic, how this stuff pops up. That'll be the case for pretty much every user. Another way you can look at this is you can run this command right here. So lusr_mgr.msc. So let's do that. So run lusr_mgr.msc question mark luser_mgr.msc. Yeah, that's pretty much it. And whoa, look at that, it takes us back to where we just were before. So a lot of the Windows system is you can get to the same place in multiple ways. So that's also why they're showing you this, is just to realize that. And then, let's see. So now that we're in here, we got two folders, users, groups. Users, it's gonna give us a long list of users. And then the groups, it gives you the name of the local group along with a brief description for each group. Each group has permissions set to it, and users can be assigned or added to a group or taken away from a group by an administrator. When a user is assigned to that group, that user gets all of the permissions of that group. And one user could be assigned to like multiple groups and have lots of permissions, or maybe they're assigned to one group and just have a few, or however it shakes out. So that's what you can do here. I can basically, if I wanted to, I could give the TryHackMe user more permissions or less, and an easy way to do that would just be by adding them. these different groups, and you get a name and a description. So, down to the questions. What is the name of the other user account? TryHackMe Billy. Sweet. So that's the right answer. Hopefully that's not too difficult to see, but it says it right there, TryHackMe Billy. So that's what that is. And then what group is this user a member of? Do I go to properties or can I just go to groups and see it? You know what? I bet you I can just go to properties. Member of remote desktop users and users. So just right click, went to properties, found that. So what group? So he is a group, he is in the group remote desktop users and then users. And I knew to put that comma there just because they kind of give you the answer format. So that's why you have to put that in there. And then the next question, what built-in account for guests? What built-in account is for guest access to the computer? And that would just be, if I go back to users, probably guest, question mark. Yeah. pretty straightforward. And then what is the account description for who? It's got to be this one, because that's weird. Okay. Oh yeah, because if I wasn't sure about my answer here, which I was being sarcastic, but whatever, then you can actually see that it is for guests right there. Okay, so window, $, fun, 1 exclamation point. Is that it? Window, is it window or windows? I bet it's window. Yeah, it is. Okay, sweet. So then you've answered that. So hopefully now you understand a little bit about user accounts, how you can be an administrator or a regular. Each one of those has a profile, and with that, you kind of get some basic folders and stuff. And hopefully now you know a little bit about permissions and groups and how that all comes together so you can organize lots of people. So that's task 6. Now that we're done with that, it's on to task 7, user account control. So this is what I was talking about earlier. Most home users are system administrators in their home because, you know, you can download stuff, you can upload stuff, you can like delete things, you can do whatever you want on your computer because it's your computer. So you are most likely a local administrator on that computer. But it's basically going to go, you can read through this, but basically what it's saying is if you're a local administrator on the computer and somehow you got hacked or downloaded malware, that malware would also have administrator privileges. So it would make it a lot easier for it to infect the system or compromise things or what have you, or just get hacked or ruined in general. So what Windows does is to protect people who have those high privileges, they use something called user account control. And basically what that means is if you're about to do something that requires administrator privileges, a window will pop up and it'll like ask you, hey, are you sure you want to do this? And you'll say sure, and then sometimes it'll make you like put in a password and stuff. So, and you can read through all that, it'll kind of explain it. And yeah, here we go. So the example, read through all this, but the example that they give you is there's Wireshark on our Windows machine. Okay, so Wireshark, and see how it has this download button? That's because we are system administrators. Normally, what it would have, this little shield thing. So basically, if that were the case and you tried to download it, then it's going to say, are you sure you want to do this? And then it's going to ask for a password. And why is that little shield there? Because of user account control, right? Because it's just basically trying to protect you and make sure like, hey, it is your computer, you're totally in charge of it. But that means if you get hacked or if you download malware, then you know, that becomes much easier for the hacker or the malware to ruin your computer. So are you sure you want to do this? So yeah, read through that, learn more about it. And then what does UAC stand for? User account control. Sweet. So with that, we are done with task 7. Next is task 8, settings and the control panel. So, hey, what's up everybody? This is the Helpful Hacker, and today we're going to be going over the Windows Fundamentals 2 room from TryHackMe. So let's get started. We'll jump right into it with task number 1, introduction. real-time protection, right? If we look at that, it has the notification right here. Real-time protection is off, leaving your device vulnerable. So that's the answer to. So right here specifically, what is turned off that Windows is notifying you to turn on? That would be virus and threat protection settings or real-time protection, right? If we look at that, it has the notification right here. Real-time protection is off, leaving your device vulnerable. So that's the answer to that. So type that in, and that's the correct answer. And with that, you're done with task 4. Next, it's on task 5, firewall and network protection. So But the answer to the question is going to be a USB, because that's a removable drive. And then it was, what do they call it specifically? A startup key, right? So it's a USB startup key. What did they call it? Specifically, a startup key, right? So it's a USB startup key. So that's what you have to have. If you don't. Have TPM version 1.2 or later. So submit that, and that's the correct answer. And then it was, what did they call it specifically? A startup key, right? So it's a USB startup key. So that's what you have to have if you don't have TPM version 1.2 or later. So submit that, and that's.
MD Rahman subscribed to the channel.